Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
Are you ready? Debate fans, are you ready? For the handful in attendance and the thousands watching across the world, brought to you tonight by Jeranism, the #1 YouTube channel in all of existence. Ladies and gentlemen, let's get ready to rumble!
Make sure your argument is tight. Wait, what? You must got proof if you so right. Wait, what? Don't get dismissed on false claims, cause you gotta bring the truths and the facts. It don't matter if we talking about racism, sexism, scientism, paganism, socialism, communism. Talk about capitalism, atheism, globalism. What about creationism? It don't matter what the ism. Live on debateism.
Welcome everybody to another episode of Debatism. It is a off night for us, but we are here nonetheless, and we've got the battle of myself versus Craig. Fight the fat shirt, or he doesn't want to be called that anymore. He says he beat the fat shirt, so that's up to you to decide whether that happened or not. But let's see here. Oops, I need to start that video, not stop it. There we go. Let me get you the thumbnail real quick, and we will bring Craig on. There you go. Earth shape, is it what we were taught or not? You can probably guess which side I'll be taking. Let's bring Craig on, if we can do so. Craig, are you there?
I am. Hello. How are you doing?
Good. Everything go good with the start of your show over there? Everything's great?
Wonderful. We are.
I think I saw you shake your head no when it said that the Jeranism was the greatest channel in the history of the world, so that's weird. Already you're offline. So, all right. Let's I'm going to let you call the coin flip because you're the guest here. Let me bring this on the screen. Whoops, where is it? There we go. You can choose either Bill Nye or Neil deGrasse.
Well, Bill Nye doesn't even have any more than a bachelor's degree, so we'll at least go with Neil deGrasse Tyson.
At least he wrote a paper. All right, let's go. And it is
double NASA's budget.
You get to double NASA's budget. All right, which one do you want to go? Want to go first or second?
I'll go second.
Okay. How lovely of you. Let me get this up here, main. All right. And we've got a 3-minute clock ready to go. All right, and if everybody's, if you want to get involved, ask questions to either me or Craig, you can do so via Super Chat, although we will get to those at the end, or Rockfin tip. So you can do that. We will catch those at the very end. We're going to try and stick to the format, at least, I think, for today. So we're arguing blind or debating blind, meaning that neither one of us have shared anything with the other, which could be interesting. We'll see. So I'm going to go ahead and start mine unless, real quick, Craig, tell everybody who you are, I guess all that stuff real quick.
Hey, I'm Craig from the channel FTFE. Probably have heard of me because Jeran likes to make fun of me. I defend the globe, I guess you could say, on my channel because I think that is the objective truth and I have evidence that supports that. I like to debate flat earthers. I enjoy the conversation. And I do enjoy talking to Jeranism because I actually think that he's one of the easier flat earthers to talk to. I've seen that he can actually run a productive conversation in the show. So I'm very happy to be here. Thank you for having me.
All right. Sounds good. And everybody knows who I am. Jeran on the Jeranism channel. Find me, jeranism.com and all that fun stuff. All right. Let's get it on. And we got 3 minutes starting now. All right. So obviously my name is Jeran and I'll be taking the position today that the earth is not what we were taught. So it is not the spinning, processing, zooming rock through the vacuum of space. I have several issues with that, and we will discuss those today. Mostly the evidence of said speeds are crazy. Just the speed that they say we're moving right now, 1.2 million miles per hour. which we all know how fast a bullet moves, which is about 1,500 miles per hour. So as we sit here, still as could be, still lakes, still glass of water next to me, we're actually moving about 800 times faster than a speeding bullet. Now, people can believe that if they want, but as long as they admit to themselves that they believe it, because men have told them, they have no direct evidence of this. There's no evidence at all that you're moving at anything. But again, just because some guys can make up some stories and tell you, oh, well, there's stellar aberration, or, give you these kind of things. If you want to believe that, go ahead. I choose not to. I know that they lie to me about things that I can touch and go and verify right here on Earth. So to think that they're telling me the truth about things trillions of miles away would be ludicrous. In fact, if you put yourself in the position of imagining that you basically have always been taught since you were a child that the Earth was stationary, and then imagine that we're trying to convince people that no, actually it's not stationary. It's actually moving forward at 32 times the speed of a bullet and spinning 1,000 miles per hour. You'd be laughed at. We'd have so many people saying, you're crazy, the Earth isn't moving. But it's just because we were indoctrinated at such a young age and put this in front of our faces. Well, now you've got people on Craig's side that will be laughing at people like me because I say that we're not spinning. And simply, it's not because they know, it's because they were told. So I find that to be embarrassing on behalf of the Globers. Also, as I mentioned before, Globers love to point out the movie that I was wrongly portrayed in and that they completely took out of sequence scenes to put them at the end. But I found it to be hugely indicative of exactly what I thought the whole time, which was that globe earthers will accept anything as globe evidence and will ask nothing. They never know, not one globe earther has ever asked me for any bit of science or data from that experiment. They've never asked for a thing. They just assume that it means that the Earth was curved and that it was proven. But if we ever say, hey, we looked across this lake and we see this, a light too high, then they want to know all the data. They want me to get temperature data. They want to get differentials. They want to get the height between the water and the sky. And you got to go every mile out in the water. It's just ridiculous to think that I'd be able to do all those. So anyway, I'll be able to show you tonight that we've got a few claims and a few questions that should expose Craig for his religious belief, which is what it is. It's not anything more than that. He believes it like it's a religion. All right, Craig, you got 3 minutes. You get 1 minute to reboot that first, rebut that, and then you can go into your intro.
Okay, so a lot of that was, personal incredulity. It's big speeds. I can't believe that. When you study physics, one of the first things that you understand is that speed is relative. So all these numbers, that's brilliant, but it's all relative to something. And, speed is not an issue, in the globe model. And just to say that I don't believe it is just personal incredulity. But quickly, in regards to the movie that you did, I will back Jeran up on this from research that I have done, speaking to people that were involved in the movie, as well as people on the flat Earth side and the globe side. Jeranism's experiment was misrepresented. And personally, I would very much like to have Jeranism explain what he did, to hear it from him and the data that came from that experiment without the bias that was clearly implied in that movie. It was funny and he never lived down interesting, but for the purpose of fairness, even though the Earth is a globe, what Jeran did in that movie didn't prove anything either way.
Thank you. Okay, and you can go ahead with your intro. 3 minutes.
Right. So for me, it's very simple. I don't just believe what I'm told. I like to test as much as I possibly can. And to claim that I have a religious belief is something that I will strongly disagree with, because even people on my side don't like it when I say that I don't feel like I have beliefs. I try to base my position on evidence and what that evidence would suggest logically. I've personally measured the Earth's rotation. I've personally measured what gravity does and verified the predictions of gravity. I've personally verified that the curve exists, and so have many people that I personally know and talk to. And there's so many experiments and measurements that can easily show that to be the case. For me, a lot of the problem with flat Earth comes from ignorance, and in general, ignorance isn't a bad thing. Ignorance is something that can be solved. ignorance is just you don't know something. But when it becomes willful ignorance is the problem. And I mean, I see a lot of that in flat Earth, unwillingness to accept facts that can be presented, empirical evidence that can be presented, physical constants of the universe that can be verified. It's pure unwillingness to even look at this, which leads to what I feel is willful ignorance in regards to reality, which puts a block on being able to actually find out the truth from what I see from a lot of flat earthers. I'm not trying to put all flat earthers into a bubble. They all do the same thing. There is some that are more genuine than others, but I see that flat earth is a problem that stems from ignorance and not wanting to actually understand the world. And if you were to test the world and understand the physics that you are testing, then there's only one outcome that can come from that. I went and studied because I wanted to know these answers. I was in the military and I applied the knowledge that I learned in real time. Engineering taught me that gravity is 100% a thing. I'm not saying that everything that we are told about everything is true. We're not. A lot of history, is manipulated. History is written by the winners, right? So I'm never going to say that everything that we are taught is always 100% true, which is why I like to test these things. And for me, it was as simple as testing if the Earth was rotating based on what I understand of physics and seeing if that test gave an outcome in either way. And when I tested to see if the Earth rotated, it did. And that test not only showed that the Earth rotated, but compared with other data from other people's tests, showed me that the Earth was a globe. I don't need to believe what someone else has told me. I will figure these things out and test them because I think that's quite important. Not everyone is in the position to do that. And some tests and experiments will cost a lot more to actually do. Science is repeatable, but that doesn't mean it has to be repeatable by everyone in the world all of the time. Everyone's got the money to build a super collider. But when you actually follow science and do the experiments and do the tests, the outcome is always the same, and that the Earth is a globe and that the Earth is rotating. And I want to go through today a bunch of the evidence that supports that and see what Jeran says in response.
Okay. As far as my rebuttal for that goes, first would be if I were going to tell you that you were spinning or flying through space at, 5 million miles per hour, I would also say, oh, well, as children, we all learn that speed is relative and it's not a big deal on our model that you can go any speed and you would never know, which is crazy to think that if we were all of a sudden told that we were flying through space at 7 quintillion miles per hour, that none of us could argue that because we don't feel it anyway. So what difference does it make whether we're going 1 million or 7 million or 7 quadrillion miles? Wouldn't matter. As far as him measuring the spin of the Earth, I'm assuming he means by doing the Foucault pendulum, in which case that can be ascribed to something else. It can be ascribed to the sky moving around us. It would have the same effects, exactly the same effects, and I can show you several places where that's said. Besides that, he says he doesn't have beliefs, but I think we'll be able to expose tonight that basically it's all beliefs, and it's not predictions, but postdictions. Okay, this is what the globe is made up of. Is they try to give you this idea that things all work out perfectly, and we expect this and we see this. Well, I mean, anybody can say that too. I can say, expect to see the sun rise tomorrow if the Earth is blank, and then the sun rises, and I go, okay, well, that means that the Earth is blank. No, that's not right. That's not how you do science. But that's how they've taught them to do it. So anyway, let's begin. I guess I will go first with my first question to you. So my question would be, can we bring boats back? Because I keep hearing I keep hearing globe Earth proponents say that flat earthers are lying, that you cannot bring boats back. Then they try and give some convoluted explanation of it. And I've never even heard somebody say that we can always bring them back. Obviously, there's a limit to vision and a limit to telescopes and a limit to cameras. But the claim or the thing that I've done myself, and that's why I'm asking you, is that when you go out and you look at the horizon at the beach and you watch a boat going out, when it becomes impossible to see that boat with your eyes, if you grab a telescope or a camera, you can bring the boat back. Does that happen or not?
As long as it hasn't gone over the curve of the Earth, yes.
Right. Okay.
So, am I able to clarify it? Is that okay?
Sure.
So, when you watch a boat go out and it's like a little fishing boat or something, it will seem to just disappear, right? It won't disappear bottom up. It will seem like it's gone. And if you get a camera and zoom in on that, you can probably bring it back. But that's to do with the resolution of our eyes and cameras, and the boat has become too small for us to resolve. If you've got a larger boat, like oil tankers or something, you can physically watch them go over the curve of the Earth, so part of it is blocked. And at that point, no amount of zooming will bring back what has gone below the curve of the Earth. And I can demonstrate this with a video by Dazza the cameraman, if that's okay, quickly.
Sure. While you bring that up, let me ask you, so you said, big oil tankers, things like that. Okay, let's go back to the year 200 BC or somewhere around there. And there would have been no such thing as a large tanker. There only would have been small boats. So explain to me then, they were all completely wrong when one of their main proofs of the sphericity of the Earth was that boats went over the curve. Because what you just said is that to our eyes, we see boats disappear, and then we can bring them back with optics, meaning that in every case, in every situation in ancient days, when they say that the Earth is curved because boats went over the curve, they are incorrect, right?
No. What they would be able to see is the boat disappearing, and they would look through a telescope and look closer.
No. I said 200 BC. I said 200 BC.
But again, you still have bigger boats then than little fishing boats that you get today. Plus, you would have things like the masts would be the first thing to come into view. And that's why you had the crow's nest in ships back 200 years ago, in 200 BC or whatever. You have the crow's nest high up. So the person that's high up could see the furthest over the curve of the Earth. And the first thing they would see is another ship's crow's nest. And they would look at it through their telescope and see that, the other ship is coming over mast first. And they'd say, oh, there's a ship coming from that direction. But it just depends on the size of the ship and, how clear the visibility was, what they were using to view it. If it's too small, no, you just can't see it because the resolution of your eye is not good enough. But if it's big enough, then you can see it. Like with this video that Dazza the cameraman did, where he recorded these 3 oil tankers and he took a screenshot when he was zoomed out and zoomed in. And I'll just skip to the end where you've got both of them. So on the top there is the when they were zoomed in. On the bottom there is when they were zoomed out. And it was from a video, not just a picture. So he did it in real time. And this shows that no amount of zooming in actually brings anything back that has gone over the curve.
Okay, so imagine
if the ship was too small to see, then it would come back in one.
Can we see a zoomed out view just so we can see both those boats next to each other?
To here,
or can you get about halfway zoomed in there?
I'll show you the point where he takes the screenshot of right. So he screenshots
That's probably
it
good
here.
there. So I want you to think about the difference in the heights of those boats. So you believe that there's a curve between that boat being at the apex of that curve and then that boat being on the other side of the curve. That's how drastic the Earth curves in that short distance. Think about where Think about where the bottom of the back boat would be. So you're probably talking maybe as low as that bottom of that red line or the top of that yellow writing. And so you're meaning to tell me that the curve of the Earth goes up, hits the apex at that boat, and then is quickly low enough to be holding that boat on the other side of the curve. That's what you believe?
Well, what you have to also understand is that everything we see when we're looking through the atmosphere on Earth, it is undergoing refractive effects.
Of course.
If there was no atmosphere here, if there was no medium between us and these ships, then the view would probably look slightly different to this. But because there's refractive effects, things might be more extreme or less extreme. But the fact that there is something physically hidden that can't be brought back is the point.
Well, I can show you that with a magnifying glass. So I don't know what you mean by that. That just because something's hidden, we have to figure out the reason why.
Right?
What?
You still wouldn't be able to bring back what has disappeared.
No, but but what does that mean that it's a curve?
Conditions are due to. Sorry, I didn't mean to interrupt.
No, I was just saying, how does that mean that it's curved? Just because your supposition is, oh, if things are behind the edge, then therefore the Earth's curved, doesn't mean that that's true. Right.
Well, agreed. That does, because I'm not putting up an if P then Q. It's as simple as that. For me, this is just one bit of evidence, right? I wouldn't look at this and go, oh yeah, the Earth's 100% a globe. I would take this into account with all of the other evidence that we can see. I've I've heard the claim that we can, see the boats go over, and I've heard the rebuttals that that we can't, and that you can bring things back. And I've looked into it, and my research has shown that when you have things that are big enough, you simply cannot bring something back once it has gone beyond the horizon, whatever that horizon may be it the curve of the Earth or something else. But there is something physically blocking you seeing what is beyond that horizon. And you're right, this doesn't prove anything. This is simply one bit of evidence that I would put with the whole.
Okay, sounds good. That's my first question. So because I do hear people say we don't bring boats back, but you understand what is meant by that. It's not a forever thing. Yeah. Eventually the boat would get too far that it just kind of fizzles in, or it shows a reflection of itself. People take that to mean it went over, or you might have some sort of effect like whatever's going on there. Okay, go ahead.
Right. So my time for a question, yeah?
Yep.
All right. Let me get my notes. Right. So it's a simple question, and it kind of goes towards the experiments that like you've done with laser tests and that. And the question is simply, would you accept the results of laser tests if they showed that the Earth was a globe, if all of the refractive effects were taken into account?
No, I mean, not if you're meaning that we get some result, but then we have to plug in these equations and then they end up giving us a result. And then from there, we take those as being gospel. No, I mean, if you're talking about if we were to shine that laser, if we were to get a laser that could hold a beam divergence of less than 6 inches, and we were to, basically thread the needle between those 3 holes, and it came back at the far side at the height that would be required of a curved Earth, especially at 4 miles. 4 miles was a 10-foot difference, right? 10-foot difference between the flat result and the curved result. Sorry about that. I would say that if I saw that, it would be pretty much impossible to explain that with a flat Earth. So, the same thing is kind of true when it comes to the fishing line experiment that, Mitchell from Australia tried a couple times. I think that the line kept snapping. But that's another one that's, I do conduct tests, which I don't see any globe earther ever do, that could change my mind. That, if I were to really feel like the test was done correctly and it's repeatable, right? So it's, also another thing about my experiment, nobody ever asked exactly how it was set up so they could repeat it. Nobody in the globe earth is interested in repeating any experiments like that. They're just interested in making themselves look good, or they only put up on their YouTube channel whatever they, basically the observations that lead towards a globe, that's what they're going to show. I never see a globe earther, I've never seen one put up any kind of anomalous result. People get on me and say like, oh, you took down your ISS footage. No, I didn't. They're all on Odyssey. All my videos came down. But the fact that I posted videos of me seeing the ISS cross the sun and the moon, that's me showing people that I'm showing you what I'm really finding in my results. Any other person would have just hid that. They wouldn't even have told anybody. But for me, I'm not looking to grow in audience and I got to make sure I keep my flat Earth audience happy. No, I'm just going to keep publishing whatever I find. I don't see that from your side at all. I guarantee you've all done experiments and all done observations that don't turn up with globe results, but you would never tell us that. That just shows the dishonesty of globe proponents.
I'd like to personally repeat the experiment you did and talk to you more about what it was that you were actually trying to achieve with that.
Well, there's 2 different experiments. This was tough about it, right? Goes
more to asking how would you control for the refractive effects? What would be your methodology to make sure that what you are seeing with the laser is actually what we are seeing? Because I can't believe that right?
I can't believe that a laser light would follow the exact curvature of the Earth. I just can't believe that. So if we were to cut holes at the same exact height above water, and it was threaded through 3 of those holes, and they were measured exactly the same height from the water, and they were to hit the backboard at the same height that the 3 holes were cut in, there's no way that could be a globe evidence. Because
why do you say that it couldn't possibly follow the curve of the Earth? That I'm not saying that it always does, because refraction can be different. 7/6 standard means that it's bigger than the curve of the Earth, but that's not how it always is. But why do you say it couldn't? Is it just a personal incredulity thing on your side? And I don't mean that disrespect.
No, I mean, just to think that
you don't believe it, or
if we're placing panels every mile, so at 1 mile, at 2 mile, at 3 miles, there's a panel, and it's got a hole cut at the same distance from the water at each place, and then we're shooting the laser from the same height that we cut the holes, and then the laser hits the backboard at the same height that the holes are cut and the same height that the laser is shot from, to believe that's a globe is just, I would expect that from you guys, because that's how you operate. That's how whatever result is seen is what the globe expects. That's what we would expect with the refraction. We can turn Bisland's calculator up until it shows that we should see this. You guys don't do science anymore. You've left that long ago. You guys do confirmation bias stuff. What?
Like, it's more about iterative testing. Yeah, we use predictions because that's what you. No,
but let's look at Bisland's calculator. What you now say is that we never see too far. And what you'll do is you'll have somebody tell me your observation. Then they'll give you the observation. You'll go to Bisland's calculator. You'll set it up, and then you'll turn the refraction dial until the item is seen, and then you go see the refraction was this amount, and that's what you call science.
No, I mean that's not what I would do.
I've seen somebody do it. Okay,
that's just a tool. That's just a tool to check what we would expect with certain refractive conditions.
No, it's not. You do it backwards. You're doing it the other way around. No. You're not doing it that way. You're doing it the other way around. You're finding an item that we are seeing, and then you're changing the refraction till it matches that we see it, and then you're saying, okay, that's the evidence. It's the refraction. But you're just turning a dial.
We would say that these would be the refractive addition, the refractive conditions required to be able to see that. And then we would look at those refractive conditions and see if they were out with what we would expect on the globe Earth. Because again, refractive conditions aren't always going to be the same. There's variability of what we would expect to see under certain conditions. So if there's an observation that you or other flat earthers bring up to us, then yeah, of course we have to check that against what refractive conditions could be. And then we would see, right, so let's say we're doing what you say and we go to Walt Business Calculator and we change the dial until it's within view and it gives us a certain refractive condition. Then we can look at that refractive condition and say, well, is that possible based on the conditions of the day? And that's why I say that when we do an experiment like that,
but you guys use them for anything.
Parametric pressure and stuff along the point, right?
Yeah, but I've seen you use it for any observation, meaning nobody cared about what the actual temperature was. It's that's how you guys explain Canigou. You say, oh no, Canigou can be seen because we just turned the dial. Well, what do you mean? You don't know what the temperature was on the day that observation was made, so you're just making it up. You're just assuming that because Bisland's calculator shows that it's possible in some magical world that it's the truth, that is evidence of why we see what we see.
Again, sorry, apologies. Again, that's not the way that I would see it. I would see it as testing a claim, right? So the claim is that a flat earther shows us a massive picture that shows something that we shouldn't be able to see on Earth. Correct. Under any circumstances if the Earth is a globe. So what we would do is we use a tool like Walter Bisland's calculator to see if that would be possible under any conditions on Earth. And then that would show that it's not proof of the flat Earth. It could be considered as possible evidence for the flat Earth, but at the same time, because it's within what we would expect the refractive conditions to possibly show, it could also be evidence for the globe Earth.
Okay. Do you know how far his calculator goes? I mean, I know that you would call standard refraction 7.6R. Do you know how far that dial goes? At what point does it stop? Is it 9.6R?
Sure, entirely. I personally don't use Walter Bisland's calculator a lot. I think I've used it maybe 2 or 3 times during debates, but I find it's a bit too complicated for the simple things that I am trying to show. Gotcha. If I need more complicated things to be shown, then Walter Bisland's calculator is great for that. But in general, I don't even, if anything, I like to use Mick West's one because it's a very simple demonstration of what we expect refraction to show.
Okay, I'll go to my second.
I'm not going to deny that I use these things because I do, just because they're a tool that can help demonstrate a thing. But I would never use it as proof of anything. I would just say, right, this gives us parameters that we can vary to see if it falls within parameters that could still be explained on the globe.
Yeah, I guess we're talking about people like Dave McKeegan, those kind of guys that have a big audience, and they're just able to tell everybody we don't see too far because we go to here, bring up this calculator, and we move this dial, and we see that everything we can see is explainable. But let's go to the second question. Mine for you is: do things in the get smaller?
Not physically, no, but they appear smaller the further away they go.
So optically, yes.
And there's a formula to calculate exactly how big they would appear. It's oh goodness me, I can't remember it these days.
So optically, they get smaller.
Yeah, well, they appear to be smaller because they're further away. Like, let's take a mirror, for instance, okay? When you look at your image in the mirror, the image that you see in the mirror is exactly half the size that you are. That's because the image in the mirror is, well, let's say the virtual image in the mirror is the distance you are from the mirror times 2. So it appears, twice as small as you actually are. And it's the same as looking at anything. A car goes away, you could hold up your thumb and it could, not cover the whole car. But once it's gone 20 meters down the road, your thumb's going to cover the whole car. Just They appear to be smaller.
Yeah, I think they call it like halves and doubles or something like that. But okay, so if that's true, that things do get smaller or appear smaller in the distance, do surveyors take into account the reduction of size of items in the distance?
Yeah, I mean, they're not measuring the size of objects. They're measuring angles between points.
Right. So if an item that is getting smaller, basically, if I've got a fence post this high and I'm now leveling my, transit or my theodolite, whatever it is, and that fence gets smaller in the distance, does the optical equipment know that it gets smaller in the distance, or might it mistake that for curvature?
Well, no, you wouldn't mistake something getting smaller for curvature. It's only when things are hidden that it becomes explainable by curvature. Let's take a surveyor looking through a theodolite to another theodolite that's an X distance away. Obviously, that other theodolite is going to be visually smaller than it actually is. But what the surveyor will do is try to sight the theodolite's view onto the center of the other theodolite to check if things are level, to get a reference point. In the actual height visually of the thing in the distance is irrelevant to that measurement. It's just about the angles that things make.
Okay, I'll be able to show that.
I don't know if I explained that the best, but I hope I at least got through what I meant.
Well, I'll show you in the claims section, but you guys have the, I guess what's called orthographic view, Muppet vision, whatever you want to call it, the side view that everybody wants to use to line things up. And in that particular case, clearly the items getting smaller in the distance isn't seen because everything's going to be left to right the same basic height. And I'll be able to show you where there's things, evidence that we have that shows that is not a correct view to ever use, because there's instances where straight lines will be drawn and you should be able to see something, but you can't see it optically. And that's because of these phenomenon and the ground being
just from the side, isn't it? I mean, it's when you have to think of orthographic view as a third person looking at something from the side.
Right.
So whatever their view of the size of things would be is important. What that third person is seeing isn't going to affect the visual.
Let me show you something real quick, and you tell me if you can see this or not. I don't know if I'm used to setting this up for other people. I don't know if this will work. Do you see this if I put this here? Can you see on your screen or no?
Be that larger on my screen, 2 secs.
I don't know how to do this so that I can have you see it and me and my audience.
Are you good boy? Did Santa bring you anything nice?
Yeah, I guess so. Got some good stuff. Let me see. Can you see that box there or no?
Yeah. Okay. What we're saying.
Just so I can, oops, let me try and get this. So if we have what I mean by that is if you've got a vision, like a Muppet vision, if you want to call it that, and we've got a ground here, let's say it's water. Shoot, where's my little thing here? This one. Okay. So we're looking across water, and let's say that there's something that's, I don't know, this tall off the water. We'll say this is, 2.5 inches here. And then this item here, your camera is here. Okay. So we know this is our setup from the view. Well, if we draw straight lines like you guys want to do, and you'd be able to draw a line from this camera and say, yes, we can definitely see this item here, but we have evidence that shows that even at that height that the water is covering that item. So, and this is barely at 400 feet away. So that would tell you, and I'll show you that in the claims, that clearly you cannot use this to decide whether or not we can see something, because there's optical effects in the actual observation. Maybe not for the third person, maybe not for this person standing on the side, but there is for the person standing behind the camera, and there is for the camera, and therefore any claim of things going over the curve don't necessarily need to be taken to be true at all, because we can show this, and I'll show you that there's an item that fell behind the curve, but is clearly above the camera.
Right. I honestly think it's a misunderstanding of exactly what orthographic view is for. It's not to say that they're actually looking through the atmosphere towards that. It's just a representation of something that is usually set to a scale. Right. And it's as simple as that. And so it's what architects would use for a certain view of something from the side. But also,
isn't this all Randy's entire reason for not being a flat earther anymore is because he had a little tower here. He was sitting up, here, and then there was like a mountain that is seen behind this tower, right? So if you go and draw a straight line and you say, can he see that mountain? And the answer is no, but yet it's supposed to be seen because it's actually taller, right? So, I mean, if you take the math of it, the mountain should be up here. But because in his image, the mountain is shown here, then he's determined that he's no longer a flat earther because this diagram orthographically shows that he should be able to see the mountain higher than the tower, but he didn't. Correct?
Okay, I wouldn't say that the orthographic view is the entire reason. It was the entire observation that he just couldn't make sense on a flat earth based on all the observations that he's ever done, all the things that he's had to say would be true if the earth is flat. The observation alone just disagreed with all of the things.
With all the 2 years worth of observations that he made and 2 years worth of showing up on my show and talking about all his observations, the one image changed his mind on all that?
I mean, it wasn't just that image. It was a combination of things. But from what I understand, it was that image that pushed him over the edge. There was a lot of things that he couldn't ever explain. That he tried to explain it by saying things that he now says that were incorrect. But all the observations that he's ever done brought him to this conclusion. I can't say personally exactly what it was that made Ranty say that no, he doesn't any longer think the Earth is flat. Do I believe him? Yes, I think he's speaking what he thinks is the truth. But I couldn't say exactly what that was. But I would say that the orthographic view isn't the proof that did it for him. But that observation in general was a big part of it. And he used the orthographic view as just a part of the explanation.
So the orthographic view is the GeoGebra view. Correct?
Yes. You would use, I guess.
Because a lot of people bring GeoGebra to me as if it's some sort of Bible. So if it works in GeoGebra, then it works. It's period. We need to accept it, and that's the way it goes. So possibly I can show in the claim section what I'm getting at there. But go ahead. You can ask your second question.
Right. Okay. So my question is, where am I getting my internet from right now? Because I recently changed my internet to Starlink. Mm-hmm. And I've looked into a lot how Starlink works. Just want to put this up here. That can be muted though, it doesn't need sound. So when I was setting it up, it was on a table in my garden, looking at the sky. And it finds its position and then stays in that position. And it's a phased array that has 100-degree field of view. Mm-hmm. And that field of view can see, what's in the sky. And I've checked from the position that I've installed it there. If it's got 100-degree field of view, there is no cell towers anywhere near that it could pick up based on its own field of view. I also checked to see if there was any balloons in the sky, and as far as I could see with my telescope and from any tracking records, there was no weather balloons around to be able to give that. It is installed in my garden. I'm not connected to any wires underground. It's simply that router back there with a wire going out to my garden, to my antenna, looking at the sky, and I get way better internet than I've ever had. So it's simple. My question to you is, where am I getting my internet from?
Well, I don't have evidence of it, but my guess would be airplanes. My guess would be that they've created a network of airplanes that are basically transmitting signals to the ground. I don't think it'd be very difficult to do. I think you could create a mesh network quite easily. I think the problem with most people is that they get locked into this, whatever we were told has to be the truth. And then they forget everything else. It's like people who act like, it's insane to think certain things are happening, and then you tell them that there's 1,000 balloons. You just said you looked up and didn't see any balloons. There's 1,000 balloons that go up twice a day from 1,000 locations on Earth?
Not 1,000 balloons from anywhere that I've checked. Not saying that it's not a lot of balloons, but the biggest one I saw was about 750 balloons. But again, you can track them. There's websites that show you where they are.
Well, there's a website that shows you some, but there's not a website that shows you all 1,000 balloons that go up twice a day.
But radar would be able to detect these things, and radar doesn't show that there's balloons where you would need them constantly. Also, airplanes would show up on radar, especially up that high. And there's
no, I'm talking about the airplanes that are above you.
Massive network of radars.
Is there a massive network of airplanes? Is there a massive network of airplanes above you at all times?
No.
What do you mean?
There is certainly not a massive network of airplanes that are transmitting signals that my satellite can see within the 100-degree field of view. I can even go into the app and look and see specifically which satellites I'm connected to at any time. And it matches all the tracking data, and you can see watch videos of them.
But literally, you realize they could put anything on that app, and you would have said the same thing right now. Literally, they could have made up satellites, they could have made up names of them, and you'd be like, it matches what I expect, and therefore it's true. Do you understand how easy it would be to be deceived?
You're saying about the massive network of planes that are all transmitting this. What network of planes?
Airplanes
have the ability to do what Starlink satellites do, and is there any evidence of that claim that all airplanes have these on?
I just think it'd be very easy to do. That's
airplanes with a 100-degree field of view of that antenna.
What?
It's that, but the airplanes fly way too low for there always to be airplanes within the 100-degree field of view that the antenna has. It can literally only see within 100 degrees of what is there. I've even installed it a bit higher than that.
What do you mean by 100 degrees? You're talking about that? I guess I can't really see what that is. That's a flat. That's a flat disc, like a flat dish.
Yeah,
I've never seen the dish.
It's called a phased array, which means that it uses clever electronics inside it to direct the signal. Where did I just put my phone? Let me get the screen up, and I will show you.
So it basically is always trying to pick up one of the satellites.
This shows what my antenna can see, and that blue bit is its field of view. These red bits on the side here is where it's seeing the building that it's next to. I couldn't get completely free, but that is its field of view. That 100 degrees around it, and
you don't think that 100 degrees up you don't think there's planes always within that area?
No, planes fly way too low for there always to be planes within that 100-degree field of view. But because the satellites are in low Earth orbit, they're high enough for there always to be, from what I've seen, at least 3 or 4 satellites able to connect to this. The planes fly way too low for that 100-degree field of view for there always to be planes in.
Okay, I'll check that. I didn't know that. Didn't think about that. But balloons is probably what we've always thought. But again, I guess the problem becomes, how do we find evidence for that? How am I going to show you that there's balloons up there? Now, just in the fact that there's 1,000 balloons launched twice a day from 1,000 locations on Earth is enough that I think should wake people up to the fact that they are not told that. People don't know that. People thought before that there wasn't balloons up there. Then we showed them, no, there is balloons that go up twice a day from 1,000 locations. Where are the whistleblowers we would always hear? Well, where are the people saying that they're one of these 1,000 people that launches these balloons twice a day? You're not hearing from them either.
It's not like that's hidden information. You can find that. It's just not widely known because I guess it's not popular knowledge. But
correct, yes.
You can find out this information. And also balloons can't follow a trail like you can see the Starlink satellites doing. The image that goes around of the balloons, it looks like a bunch of balloons launching up in a trail. That image that flat earthers like to put around is actually a time lapse of one balloon being released, and is not a line of balloons going up.
I don't even know what you're talking about. But
other people probably might, and I'll show you. I'll send you the image that I'm talking about on Messenger another time. But for balloons to do this, they would need to always, again, be within that 100-degree field of view of the phased array my antenna uses, which would mean they would have to be, really, really, really high, probably higher than the weather balloons go, for there to be a constant stream of them over there.
Well, I think from 120,000
up there, as long as things like the Starlink satellites, and you can use the app to actually track the number, the registration number of the satellites. And if it was new balloons being launched every time, then...
So you believe that let me just make sure I understand this. So there's a box that's flying around the Earth, it's falling around the Earth, many of these boxes. I think there's this eventually supposed to be 12,000, right? And
It's got about 7,000 at the moment, I believe.
there's 7,000 now. I didn't even know.
Let me show you again.
Hold on. So these, I just want to make sure I understand the claim.
Starlink tracker app that I use, and that is the Starlink constellation of satellites. I don't know if you can see, but those green dots there.
Okay.
One of them is the ISS, and one of them is the CSS, the Chinese space station.
So these are falling around the Earth, all these satellites, and they're all what?
They're moving 27,000 miles an hour, and then the green ones are moving 17,000 miles an hour.
The Starlink's moving 27,000 miles per hour?
Yeah.
So
and if you zoom in really close, you can actually see it in real time. So let's go over Russia right now. Zoom in.
So they're moving. Hold on, they're moving 27,000 miles per hour. They're falling around the Earth, and they're transmitting a signal from a TV signal down to, or an internet signal down to you, or you're
yeah.
And they're just it passing it off when one falls out of the way, then it passes off to another one, or how do you not get any? Because
there is always satellites within that 100-degree field of view because they're so high up. So my antenna looks southeast, and I'm in Scotland up here. So at the moment, it's all these satellites that are down here.
So how high up are they?
They're slightly lower than the International Space Station, I think, about 230, 240 miles. I might be wrong. But they're in low Earth orbit, and they're slightly lower than the
But they're not moving
International Space Station.
27,000 miles per hour then?
Yeah.
How could something lower than the ISS be moving 27,000 miles per hour and staying in?
Double check. Like I said, I may be wrong about that. Let me double check.
It doesn't sound right to me, because at a certain distance, I guess. Like, here's my question: why wouldn't you put up a satellite if you're Elon Musk? Why not put up one way higher that just covers all that area? Why would you need 12,000 satellites?
The more you have, the less latency there is. Height of, I may be wrong about the difference in. So let me just double check. I don't like to be wrong. Right. So ISS is 408 kilometers. And no, I'm wrong. Sorry. Starlink is slightly higher than the ISS at 550 kilometers. I apologize. I was wrong about that.
550 kilometers.
So ISS and CSS are 550 kilometers. Sorry, Starlink's at 550 kilometers, and the ISS and the CSS are at 408 kilometers.
Okay, so it's 341 miles up, right? Yeah. So what would be the speed? Can't be 27,000 miles per hour.
Yeah, the Starlink satellites move at 27,000 miles an hour.
So what is their orbit period then?
Not entirely sure, but you can use this.
Well, it'd be like an hour, right?
On like an individual satellite. So here I've just connected to.
Well, if it's 27,000,
119, and it shows you what its orbit is around the Earth, and you could track it using this app to see where it goes.
Yeah, I'm just saying that would be an hour then, an hour to go all the way around.
If it sounds about right. I've not watched the one for an hour, but it may be. But
okay.
From what I understand of the technology involved, there is no weather balloons that could do the same thing, that could give such a low latency signal from a constellation that is constantly connected.
That we know of,
that we know of, but
no, they orbit at 7,000 miles per hour. 7,000 miles per hour, Greg.
Am I wrong about the speed?
Well, traditional satellites 22,000 miles up must orbit around 7,000 miles per hour. The Starlink satellites need to move faster to maintain. No, it says that's a speed of 17,000. I don't know. That's what I'm seeing. Anyway, it just doesn't seem like 27,000 doesn't seem right. But it looks like it's 17,000. But they would need to move. Yeah, I guess it is slower if you're above the ISS, right? Be slower. Wouldn't be.
Again, I may be wrong about that, but they're moving really fast. I'm not sure the exact number.
Yes.
I'm sure when I looked at something.
No, 27,000 didn't sound right just because I've seen them cross the sky. Not my sky, but I've seen them on video, and I was thinking they look like they're moving the same speed of the ISS or slower. So how are they moving faster?
Right. No, you're right. It is about 17,000. It is not 27,000. I guess I've got that in kilometers.
Oh, maybe that was it. The whole changes of the measure. Okay. No, I mean, to be honest with you, I can't. I don't have the answer to that. but I guess for me, I wouldn't even be shocked if I were to find out that they were able to put things in the sky. I'd be shocked if I found out that they were able to put them in orbit.
Yeah, sorry,
obviously.
27,000 kilometers an hour, not miles per hour.
Gotcha. Makes sense. That's what happens when we live in different countries. All right, let me ask the next question for you. Number 3 was, so just the evidence of stars. I'm still grasping at this one. I don't understand it. Why is it that if we know if I put a balloon up right now, if I put a helium balloon, that as it gets higher, it's going to expand. The gas is going to expand. At some point, the balloon can't even hold it anymore, and the gas explodes and goes in all directions once it gets to the 120,000 feet or so, once it gets to near vacuum. So if that is the case, so that means that everything that we've seen on Earth, at least that I've ever seen, is that gas expands in vacuums. Always goes in every direction. There's never been a case where gas has done the opposite of that. But you tell me, according to your beliefs or what you say you have evidence for, that the opposite happens in space. That if you get a lot of gas, that it all of a sudden changes its behavior and says, today I'm not going to expand into space, I'm going to pull into myself. So where is that differentiation? Where does that happen, where gas stops doing what we see it do in every case and does the complete opposite thing that we've never seen it do ever? It's just we're told that it happens. Right.
Okay. That's a misunderstanding of physical principles there. So a gas, let's say a gas in a balloon, helium gas in a balloon is under pressure. Right, it's being squeezed. There's a lot of it, which means it's got potential energy to do something. Right, and when that balloon pops, that energy becomes kinetic energy.
But why does the balloon pop? First of all, why does the balloon pop?
Let's say a helium balloon would pop because the pressure on the outside becomes too small to contain the pressure on the inside and breaches the physical limitations of the the balloon stability. The balloon literally doesn't have the material left to stretch anymore to deal with that pressure differential, right? Because there's pressure inside that balloon. Yes. And when there's less pressure outside of the balloon becomes incapable of containing that pressure until the balloon pops, right? But that means because the balloon is under pressure, it's got energy in it. It's got each one of those gas molecules, they have potential energy ready to do something because they've been squeezed into that balloon. So when that balloon pops, potential energy becomes kinetic energy. All those gas molecules move, right, in all directions. But kinetic energy isn't infinite. Once that energy is expended, then whatever other forces are acting on the gas will be the prevailing force. And gas in a vacuum just naturally sitting there, if there's a bunch of gas molecules, they're not just going to move away from each other. They're just sitting there because they weren't under pressure to have that energy to then expand. And because we can demonstrate that mass attracts mass, and we know that gas is made of mass, it logically follows that when there's no other forces involved, the prevailing force becomes that attraction between mass, which then creates everything we see as stars and planets, etc. It's all to do with what energy was there. And just one more thing to add to that is, let's say you pop a helium balloon on Earth, that helium expands into the atmosphere, but we know that in the atmosphere there is a pressure gradient because that helium will settle into that gradient, which means that it hasn't gone everywhere, because if everything just expanded everywhere, we wouldn't have a pressure gradient.
Okay. You mean in your world? You mean in your model?
If we are making the assumption that gravity is something that creates a force proportional to the product of terminal masses and inversely proportional to the square of the distance between them, then yes, that is what would happen. Okay. I
mean, I guess and this is, will always be forever the problem that we have, is that you keep claiming gravity is something that we have, and nobody's denying that things tend towards the Earth. Right. So when you're referring to gravity, if you're referring to that, then it's fine. But if you're referring to mass attracting mass, again, that's your assumption. And you say you can model that, but I'm not really sure that how are you talking about with Cavendish?
Well, Cavendish is just one example of mass attracting mass. There's hundreds and hundreds and hundreds of scientific experiments
what
demonstrating mass attracts mass with all different types of materials.
Like what? with gas?
I'm sure there is some that actually have gas specifically as one of the things in it, and I can get you the information for that. I don't know offhand. I'm doing a lot of research on different gravity experiments. Supercooled gas is an excellent way to demonstrate forces acting on it. But gas isn't a different thing to anything else. It has mass. It is matter. And we can demonstrate that mass attracts mass. We can demonstrate that things have weight. When you put air into a container, that container gets heavier because that gas has mass. And if everything we've shown demonstrates that mass attracts mass, and that matches the observations of seeing things in the sky like stars and planets and orbits, then the logical conclusion is that one matches the other, and that is what has happened. Do we have any direct observational evidence of gas becoming a star? No, because we don't live for millions and millions and millions of years, but we can see evidence that suggests that it is what happens.
And you don't think we should have evidence of gas attracting other gas to itself somehow?
Again, I'd have to look up the specific experiments that I was reading about recently, and I will try and patch that information so that you can look at it.
Okay,
but
go ahead.
Gas, mass, and from what we understand with all experiments, mass appears to attract mass at the rate described by Newton's law.
Not all experiments. Okay, go ahead, your question. I think it's comical. It's the things you say.
What do you mean by not all experiments?
I just think it's funny that you say that. I mean, that's just such a statement that is only can be made by somebody who has science as their backing. They can get away with just saying that all experiments do, prove this when they don't.
Okay, but let me rephrase then.
Okay.
All experiments that I have researched, and I don't just research for an answer, I research what experiments show. And every experiment that I have looked at and researched that tries to show what gravity does backs up all the other results. From every experiment that I have researched, they all say the same thing.
Okay.
Is that better?
Yeah, sure. If you want to, I don't believe that, but I'll give it to you. Go ahead. Go ahead with your third question.
My third question was actually very much along the same lines, to do with the same question. And it was simply to ask you if you could steelman the globe's position on gravity and explain why it wouldn't affect gas.
Well, if I steelman gravity's position, then I would say that the position is that it should also attract gas. If all mass attracts mass, which again, or if it's a curvature of space-time, either one, I guess from the steelman position, you would say it's both, that it can both be described as a force and also as the curvature of space-time, which creates the force. And then as far as you want me to steelman though, why then from that position argue why gas wouldn't do what it's supposed to do?
Well, yeah, I guess I'm just trying to understand from your position if you understand gas, and you actually answered that by saying that if you were to steelman gas, gravity's position that we say, then gas would be affected, and that's fine. That clears up the question, because in my mind, I actually had the assumption that you thought that the globe's explanation of gravity didn't explain gravity, didn't explain the way that gas behaves, sorry. And I guess that was wrong on my part. I'm making an assumption about what you thought.
Well, I would
that
think
clears
that
that up. You understand that the globe's position is that it should affect gravity, and that's fine.
Yeah, but I also recognize that we don't see evidence of that. And, just taking the idea, which I've talked about before, of a box of air and let that sit inside of a vacuum chamber and then seal the box of air in the vacuum chamber and then vacuate the chamber so that now you've got a vacuum with a box of air sitting at the bottom of it. And if we electronically open that box of air at the bottom, we know that it will immediately fill the space. What it won't do is stay at the bottom because gravity's holding it. So gravity doesn't even hold the small, but hold on, we're talking about a tiny little box of air. It would be so minuscule. Why doesn't gravity have any effect on it?
It does, because what gravity does is then arranges that air in that vacuum into a gradient.
Sure, you say that, but I could say it's something else, right? I could say that it's because it has a slight...
Measure that there's a gradient of pressure in that vacuum chamber.
Sure.
It's going to be minuscule depending on how big the vacuum chamber is.
Because it's no longer open to a vacuum.
Let's release that box into the vacuum chamber electronically, like you said.
Okay.
And once all the kinetic energy of that gas has been expended and we let the prevailing force in that case, which then becomes gravity, do its thing, if we were to measure it, we would find that there would be a gradient of pressure inside that box.
In the container.
Because it has some... Sorry?
In that container, yes.
Yeah, in the container. So now once the gas has settled, all the kinetic energy has been expended, and it's under whatever pressure it is in that vacuum chamber, there will be a gradient of pressure where at the bottom of the vacuum chamber, there's a higher pressure. At the top of the vacuum chamber, there's a lower pressure. And that matches what we expect gravity to do.
No, because
when you've got that squared distance relationship.
In your world, you have to then put that in a vacuum. Then what would happen?
Then it would expand, and once kinetic energy was released or expended, there would be another gradient, but it would be a lower pressure.
Well, the gradients would only exist as long as you're within the container of the vacuum chamber. As soon as you lose that, as soon as you expose the vacuum chamber to the real vacuum that's infinite, you're done. You can do it.
Because if you mean like the infinite space of space.
So I mean, yes.
Well, yeah, because let's say we're in space. There's no planets around. There's no big gravitational masses.
Okay.
All right.
Even though that doesn't really, that's a very theoretical thing, but okay.
I mean, yeah, we're just doing a thought experiment here to work on the premise. Okay. So there's nothing else around that could create a massive gravitational force.
Okay.
Right. So you've got that box with air in it, and boom, you open that box. What's going to happen is those gas molecules are going to release their kinetic energy and expand. And no, in that case, there is not going to be a gradient because there is no gravitational influence doing that. Now, the question is, does the kinetic energy overcome the gravitational force of just those few air molecules? Well, yeah, because there isn't a lot of it. And the kinetic energy, there's nothing then to stop in space those molecules of gas moving away because there's no friction. So in that case, when there's no other big gravitational influences, it's going to keep, and we've just released it from the container, it's going to keep it moving away from each other. But only in that specific instance. Once the kinetic energy is expanded, it's just going to follow Newton's laws and move until there's another force that tells it not to.
Okay. So when you're saying in the box that we have the air, you're saying that air is under pressure because it's in the box, and then we open it and then it goes into the vacuum, and then you said it resettles, but now is that air also under pressure?
Well, yeah, I guess it is because there's air, right?
Right.
The vacuum space isn't a vacuum. It's an extremely low pressure area. There is, let's
for
say,
all intents
for
and
every
purposes, though,
meters cubed, there's one molecule of
right.
gas.
So
right?
it's nothing we can do on Earth, though. But there's nothing we can do on Earth, so it's way as much of a vacuum as any of us can imagine. Exactly. Essentially,
yeah.
Okay.
So, but once you put some, if there's stuff there, then it's not a vacuum. So that if that air is in that vacuum, then it's not a vacuum, and there is a pressure between all that air, but it's extremely, extremely low.
Okay, gotcha. What you said, you were asking me a question. What was your question again? Oh, if I could steel man.
You answered the question straight away by explaining you can steel man it, and I do appreciate that. So it just goes into the.
I think it becomes a matter of there's a lot of just so stories, if you will, that are, sure, if I want to just believe him, if I want an easy day, if I want to just go sit on the couch the rest of my life and not actually pursue real truths, I could just accept everything that I'm told and just kind of go, yeah, well, I guess it makes sense, even if it doesn't. But to me, there's too many lies being told or things that don't contain the kind of evidence that I would expect them to when something's called science, right? When I'm brought up in school and I'm told the scientific method, and then they send me through all these things, and now that we know the size of the sun, and we know the size of these planets, we know their distances and what they're made of, and we know the distance to these stars, and then you go looking for the evidence of that, and you find out that it's just not there. Not like you would expect. You find out fantastical stories about, oh, well, we guessed that Venus was the same size of Earth, and then we did all, it's just none of it actually jives with how things would really be done. I can't even imagine that being the case. I mean, imagine if just talking about real quick, like dark matter, dark energy. If you were to ask me, Jeran, what keeps the sun and moon up in the sky on the flat Earth? If I were to answer you with dark lift, if I said dark lift keeps it up there, your immediate next question will be, well, what the hell's that? And if I told you, well, we know it's up there because it must be. And then you said, what do you mean? Where are you getting that from? And I said, well, because in order for our model to work, we need the sun and moon up there. And therefore there must be a lift force that's keeping him up there. Therefore, it's dark lift, and we're going to continue on. You would never accept that. You would laugh at us hysterically. Yet that's your model. Your model is the idea of dark matter and dark energy make up 97% of the universe. Hold on, make up 97% of the universe. You've never observed it, but you guys claim it must be there because you need it for your model to be correct. That's not science. That's not what you're supposed to do. You're supposed to throw away the theory. It's wrong and back to the drawing board and find one that works, not assign mathematical placements. What?
Right. The thing about dark matter and dark energy is it's just a placeholder. Like
right.
we you know, we're not just going to throw it away because we are investigating what is going on. We don't have any concrete answers about what it is. And all we're saying is that we can see that something is happening, right. And this makes sense that it's the explanation, and it's a placeholder for now until we've investigated and find more. If we were to just throw away that, because we don't know all the answers, then we would never figure out the answers.
Well, Feynman says if you have a theory that doesn't match but what does Feynman say? If you have an observation that doesn't match the theory, what do you do?
But it does match. That's the thing. All we have at this point is the observations. That's it.
But it doesn't match the theory. You do have a theory. You have a theory of gravity. You say gravity. You say gravity controls everything in outer space. That's why you had to assign new energy and new matter. You had to assign it because there's not enough.
Explain the interactions that we see, but we don't have a theory of
Hold on
what
a second.
dark
Would you say gravity explains all the interactions you see?
Yeah.
No, it doesn't. That's why. No, it doesn't. You're missing a ton of matter. That's why you have dark matter.
But we're not. What we're seeing is that there is something happening, and that it gives an influence that we can predict, and we don't know what it is. But it would make sense that it is mass of some kind. It's non-baryonic. We don't know what it is because we don't have a method of detecting it. But
so how do you know it's there?
That something is happening. That's all we have no theory of what dark matter is or why it's doing what it does. The interactions match the predictions of gravity if there was something there. It's like the same way that Uranus was discovered, right?
Which is another joke. I don't believe in that either.
The same way that Neptune was discovered, because we saw...
But the fact that you believe that stuff, I mean, I just don't want to go off on a tangent on that, but you have to think, you have to use your head and really think if that's even a story that's viable. I don't even think that story is viable at all.
But there's evidence to suggest it with the data that many people saw when they were mapping the orbit of Uranus. They saw, many people saw that there was an irregularity in Uranus's orbit, right?
No, I don't believe that. If
we did that and we said, right, that means that what we have is wrong, and we throw it all away, we would never have then been able to actually discover that Neptune was there.
So you're telling me...
We didn't know what was causing it, but we did more investigation, said, right, well, if what we're saying is correct, then maybe there could be something here. And we did a bit more investigation and figured that it was. But with dark matter and dark energy, we're at the very, very beginning of that. What we can see is there's something going on that maybe didn't match all the predictions we've had before, and we're trying to figure it out. Doesn't mean anything's wrong. It just means that we've got more information to gather.
It means that you're 97% wrong. That's what it means.
No, it means that we 97% aren't sure. Not that we're wrong.
No, you're claiming that there's mass there that cannot be seen. So
we're saying that there is gravitational effects that would be accounted to mass. Yeah, we can't see it. And that doesn't mean that we're wrong and that something isn't there. It just means we don't know yet. To say that we're wrong would mean we would have definitive answers. We don't have definitive answers, so we can't say if we are wrong or not. We might be wrong. Here's the thing, Jeran, right? We may be wrong about dark matter and dark energy.
No, not maybe.
Right? But maybe. We don't know yet. We have no evidence either way to say if it is wrong or right.
So what other things do we have like that and that we have no evidence of that we just proclaim to be placeholders?
That's how science works. You
name another placeholder.
Right. Yeah. You once you see an observation and you come up with a hypothesis, you give something, you make a guess of what something might be based on your observations.
Okay.
And, imagine how magnetism was discovered. We didn't know what that was. We didn't have an explanation for it. We could just see that something happened, right? We had no idea what it was. So there would have been lots of placeholder explanations. They originally thought that magnetism was an inherent attraction, like due to some demonic nature. Like there was experiments that were talking about that. But, magnetism isn't what they thought it was back then. We didn't know what it was, but we did more experiments and we found out what magnetism was, because there was observations that we could see. We didn't always know, and it would have had placeholders. The same with gravity. There have been placeholders for what gravity was for, for years, but we now understand and we call that thing gravity. And right now, we are calling this thing dark matter because we don't know what it is. We can see something happening. We just don't know what it is. We're at the beginning of the scientific investigation. That's exciting for me, right? It's exciting that we don't know.
Sure. I mean, but they should probably let people know that a little bit more. I think that people think that we've got it all figured out, where that's a pretty big problem, where you've got, first of all, without dark energy, you don't have the expanding universe, which, again, people think is observational. They think that that's happening for sure. I bet you in the coming years,
observations suggest that the universe is expanding.
What observations? What observations?
The observations of things moving away from us throughout the universe.
So you think people
there's lots of observations that suggest that the universe is expanding. Now, again, here's the thing:
there's not lots. There's just redshift, and redshift doesn't need to be Doppler because
there's lots of observations, and again, it's
like what?
Not just that. I could send you a lot. I can't tell you right now off the top of my head, but there's more than just redshift. There's many observations that suggest that the universe is expanding. The way that gravity works suggests that the universe is expanding. But we don't know why.
The way that gravity works.
It's expanding.
You're missing
right now.
You're missing 97% of the matter.
Hold on. Again, right now, we don't know why that observation is the case. And here's the thing again, we may be wrong. We might be wrong that the universe is expanding.
Yes.
Because we have no definitive proof. But at the moment, that's what our observations suggest. And
no, this is what I mean. This is what you guys.
We're trying to investigate why that is happening.
Yeah, because you're doing science the wrong way. You're coming up with a model, and then you're now putting everything into that. But yes, it's not. You didn't observe that the universe was expanding. You observed that the Earth seems to be the center. Okay, that's what.
No. We observed the universe was expanding. That's how we came up with the possibility of dark matter. We didn't have dark matter. We looked at the universe, we looked at everything, we came to the conclusion
that we were the center.
The universe is expanding.
No, we came to the conclusion that the Earth was at its center, and so they had to explain that.
At one time, no one thinks the universe is the Earth is the center of the universe now. I mean, no one thinks that the Earth is the center.
I didn't say anybody thinks it now. What I said was Edwin Hubble, when he looked out and did his observations, he saw that we appeared to be the center of the universe. So that he said that's the only thing. He couldn't disprove that postulation. So he said,
"No, you can't disprove it."
No, he couldn't.
No one knows it for sure. That's the thing. Just because we can't disprove something else doesn't mean we have a definitive answer for what it is.
Exactly.
We may be the center of the universe, but we may not be the center of the universe. Again, we don't know. No one says for sure that is the case. All we say is we don't know, and we're looking into these things.
No, you guys all say that we're not the center of the universe. What do you mean?
No, again, we say we don't know. We say that we...
Who says that?
No one has said for sure that we are not the center of the universe. No one has definitively said we are definitely 100% not the center of the universe. It may appear that we are. It may appear that we are. We don't know.
So what was Edwin Hubble... Why would he call it why would he call it then the horror of a unique position? Why is it a horror? Because
that was his personal opinion of something.
Okay.
But there is no one anywhere and no definitive answer that says we are definitely not the center of the universe or we are definitely the center of the universe.
Okay, but
it's one of those things.
So if we don't know, right? So if we don't know, then wouldn't you? Let me get this out. If we don't know, then you would have science going in both directions, looking into both models. What did they do? They erased the one that were the center, and they introduced the idea of inflation, which, by the way, is a requirement of the expanding universe. Okay, and then we have to be inflated. So what's going on there? Oh, well, we need everything moving away from everything so that no matter where you're at in the universe, everything's moving away from you. So all these things are steps to get away from the observation that we were the center. To explain away.
No, I disagree. All of it is based on observations and what our
observations show us that we're the center of the universe. That's what
the observation shows that the universe is expanding, and
the observations do not show that. So
again, we don't know if the universe is infinite, so we have no way to determine if we are the center of the universe. There's no observation that could show that because we have no data about the definitive nature of the universe.
So do we have definitive evidence of the expansion? No.
We have observational evidence. Again, no.
Okay, so we have observational evidence that we're the center. You're missing the point. The point is they're the equal stature.
Observation shows that the universe is expanding.
What does?
And
I didn't hear what you said.
Here's the thing, right?
Hold on, let's start over. Start over. You asked what you just said.
The observation of the universe expanding doesn't just exist from our point of view. From anywhere in the universe, the universe.
Guys, Craig doesn't have any beliefs, but he just told us that no matter where you're at in the universe, everything would look the same as it does from Earth.
No, this isn't my position. Again,
that is your position. This is your belief.
No, hold on. What you're doing is you're trying to get me to defend what other people have said about the universe.
Correct.
I don't talk about the nature of the universe.
You've just been talking about that for the last 10 minutes. You've just been telling me.
Yeah, because one of your questions. And no, I haven't been telling you my beliefs. I have been telling you what the current position of science is. That's not my beliefs. That's just what the current position of scientific investigation is showing.
And do you believe the current position? Do you believe where we are in the current position? That is your beliefs, is whatever science believes.
I say that the current position suggests that could possibly be the case, but I don't know. I am not afraid to say I don't know. But if we are talking about Earth, right, gravity works 100% every single time, according to Newton's laws. Every single interaction on Earth and even within our solar system in general works based on what we understand. I don't know about the rest of the universe. I don't know about the galaxy. There is nothing that can tell us definitively what is out there.
Right. So the Earth could be the most massive item. The Earth could be the most massive item in the universe that there is, and everything rotates around us. What?
We know the sun's bigger than us.
How do we know that?
Well, we measured it with radar.
we bounced radar off the sun, and it told us that it's 867,000 miles wide.
Yeah, they did several measurements with radar, determined the position.
Which would be based off of what they say the distance is and everything, right? So if anything was off, then the whole thing.
No, they used radar to find the distance.
And then when they found out, then they sent radar back to get the size of it.
They did several bounces with radar. I did. I think I actually sent you the paper for the radar thing before.
I don't think
it shows they did many experiments.
Oh, yeah, I think maybe you did. Yeah. But then I heard recently, was it with Whitsitt or somebody that said that Brown University says that the sun is a black body radiation that absorbs all radar, or all.
No, the entire isn't. No, there is areas of the sun's exosphere that is dense enough to just reflect anything. If it was a black body radiation, then we wouldn't be able to see anything from it.
Okay, so what I'd like to get your position because
the sun.
Because I've never seen anybody do this, and I guarantee you haven't done it or seen somebody do it. But I just want to make sure I understand the position. So you're saying that we set up some sort of satellite array that then shoots a radar towards the sun. Even though we're moving now, we're spinning, we're getting out of the way of that, but it's going to go to the sun, reflect off the sun, come back, and then from that we'll be able to determine its distance and its size. That's what you're saying?
Through iterative testing, it wasn't in space, it was done from ground. But yeah, through iterative testing, not just once, but through multiple experiments.
Right. So I think the one that you sent me was one that they did it over like 2.5 weeks. And from that 2.5 weeks, they got 2 return signals that matched their output. And they claimed that had to come from the sun.
No, the one I sent you had many more than 2 returns. There was actually hundreds of data points.
But the ones that matched the outputted
they do match what they expected. The ones that returned things that's marked as not returned is when they weren't aiming at the sun to test whether they
I got a different one. Send me that one. Send me that one.
Aim not at the sun, then there's no return. But there was nothing within that experiment that actually fell outside of the predicted results.
Yeah, I don't believe that for a second. I don't believe radar off the sun. I mean, that's just insane. But again, you can call it personal incredulity. There's a different, you just believe them and I just don't. You just have a name for what, and I'll call you religious and you'll call me personal incredulity. And we'll just
I don't have a belief. That is just one bit of evidence that goes with all the other bit of evidences that I base my position on.
Okay, but that is a belief. That is a belief.
Right? Word is it?
But you have a belief. You have a belief that we are not the center of the universe. You have a belief that the universe is expanding.
Philosophically, if you want to go down that route with belief being a subset of knowledge, right? Yeah. Philosophically, I have a belief that the Earth is a globe and that the Earth rotates, and that the universe is expanding. Right? Philosophically,
Right.
you can say that, yes, I have a belief, but everybody philosophically has a belief about something, because
Correct.
technically belief is a subset of knowledge. But
Sure.
I base my position on evidence, and I allow my position to be guided by what the evidence suggests.
And I would say the
That's
same
it.
thing about me. I would just say that I don't as easily give up my my mind, my senses, just because men tell me. Again, if I had all the evidence that everything that ever been told to me was the truth and that nobody was ever lying at all, then maybe I would feel differently. But I don't feel that way. And I think that to think that, you know, rich men got together and decided, hey, we got to get, you know, school books together so we can teach all these children to be as smart and as smart as possible, and they need to come take our money and come take our families' power. There's no way. What was sat around and talked about is, how do we make these families stupid? How do we make the children dumb so that they never take our money and never take our power? And that's where we are in the world today, is because they've taught people, made them think they're smart, and they're not. I mean, like, what do you let's say you think you're smart. What have you done? What have you discovered? What have you uncovered? What have you invented? What have you... Nothing.
I helped design a new ventilation system for the new warships, the aircraft carriers for the UK Navy. I was part of the design team that helped design a new ventilation system that would help protect against chemical warfare and other means.
Okay.
I have also used my engineering knowledge to develop new infrastructure for wind farms around Scotland when I was part of Enertrag UK as a project developer.
Mm-hmm.
So I've used my physical knowledge to actually advance the world, I think.
Okay, good for you. I wouldn't expect that. I would think that, like most people, they just go to school, get their diploma, and then they really don't do much other than either teach the same thing that they were taught or tell people that they've done things like invent ventilation systems. So go ahead. What is it? What are we on? Claims? I think
Yes.
you are. It's my first one.
Yeah.
Okay, let me show you this. Well, I'll actually do. Let me do this one here real quick. So when you've heard the Edwin Hubble quote read, I'm sure many times. Yes.
Which one?
The unique position, the absolute horror. We have to avoid it at all costs.
Oh yeah, I've heard that. Yeah.
Right. So I mean, I'm just wondering how that's not an issue for anybody. Like, I would have more respect for you guys if you would, Globers, if you would actually be honest with, like, yeah, that's an issue. Yeah, the fact that he said that does make science look bad. It does make it look like we have to stay away from being the center of the universe no matter what. That's what he says. He says that it's the absolute horror, and that we have to.
But that's just.
Okay, you can say that,
Sorry.
but he is the one who he's the one who they say discovered it. He's the one who it's, the Hubble expansion, everything's named after him, everything. But his reason for going in that direction was to stay away from the Earth being at the center. So, and he says, observationally, it can't be disproved. So he couldn't disprove something. So do you think, wouldn't people like to know the fact that something couldn't be disproved in science? And so we didn't keep investigating it. We came up with a hypothetical expanding balloon with dots on it, and there's somebody blowing it up, and we have to add dark energy so that we have energy now to push it out there, dark matter so that we have the matter amount to gravitationally all these things had to happen simply because some guy said, well, we can't be in the center. So, like, if it was a real world and people really cared about the truth and science, then we would have had people looking into both models, not shun one because it's an absolute horror of unique position and we got to avoid it at all costs, and then take the entire world down this direction for 60, 70, 80, 100 years. And it seems to be that we're just getting nowhere, that they've completely hit a dead end. They're not going to discover anything else in space because they've got their foundations are completely wrong. So anyway, I think if people read that book, what is it called? The Observational Approach to Cosmology. If they understood why we went in that direction and how it wasn't because we saw the universe expanding, it's because that's the only answer that makes sense other than we're the center of the universe. We're either the center of the universe and everything's moving away from us, or everywhere is the center of the universe and everywhere has everything moving away. Now, have we even gone to somewhere else and said, yes, that's what they see from here? No, we've just assumed that that's what they must see from there because we don't want to be the center of the universe. That's that's not science. And it's sad that you can't see that. And then you just go around saying that, well, all these things match what, well, yeah, but that's easy. Like what you're saying is whoever got here first and came up with some viable mechanism, whatever it might be, they could have called gravity anything else, right? Like, isn't science supposed to explain the why? Science isn't just supposed to say, oh, well, we expect this and this happened. No, science is supposed to help tell me why. That's the whole point of science, is not just to give me the what happens. I mean, we can figure out what happens. We can see what happens. We can observationally see what happens. It doesn't tell us why. Why do we see things moving away from us in every direction? Why do we see a missing amount of matter? That's what science is supposed to. And then when you
but that's what we're working on. That's the thing. Again, we don't know those answers yet. We're working towards those.
Got you, but you're explaining it to people like you do know, like, not you. I'm just saying science is explaining it to people. Science has backed itself into a corner. Neil deGrasse Tyson tells people that science is true whether or not you believe in it. So what about dark matter and dark energy? What if we discover that that's not correct? Are you telling me that they were correct anyway?
No, again, we're not saying right. So we're not saying that that's definitely what it is. We're not making any claims about that. We can't be wrong about dark matter and dark energy because we don't know what it is and we haven't said what it is or why it does what it does. We might be wrong, and I've said that many times, but
I thought you just said we can't be wrong. Can we? Hold on. I just want to make sure you said what you said. You said we might be wrong or we can't be wrong.
No, I said we might be.
Okay, so if we might be wrong about something that's considered science, then Neil deGrasse Tyson saying science is true whether or not you believe in it is false.
Again, I don't care what Neil deGrasse Tyson says.
Well, I do, because that's what he's telling people, and that's what all the little minions in your chat think. That's what they believe.
To be honest, flat earthers bring up Neil deGrasse Tyson more than anyone. Yeah, I have said many times that I think Neil deGrasse Tyson dumbs things down too much so that everything he says can be misinterpreted or even slightly wrong. I've actually I was scripting a video that I haven't finished that is literally called "Why Neil deGrasse Tyson is Wrong." Right? He's not a god. He doesn't. He's wrong all the time. Speak science. He is just someone that does something online and on TV and stuff. But he isn't the god of science, and we don't. We don't say that what Neil deGrasse Tyson says is gospel. Frankly, I couldn't care what Neil deGrasse Tyson says because a lot of the time I think he explains things very, very badly.
Yeah, I just think he speaks to a vast majority of the population. So if he's selling a certain brand of science, and I mean, like, if you guys want to know why science is being questioned now more than ever, why are people against science? It's because of people like Anthony Fauci. It's because of people like Neil deGrasse Tyson. It's because of people who are in positions of power or in at least positions of not prestige. What do you call it? That he's able to change minds. He's able to, he's in a position of, I don't know what word I'm looking for, but anyway, he's able to change minds just like. And so when these people tell lies, when they are incorrect about things, then they shouldn't be surprised when science literacy or adhering to trust the science is wrong. We were told to trust the science when it came to the vaccine, as you know. Again, I'm just saying that we were told you would stop you from transmitting it. You would stop you from getting it from somebody else. And then after all this was done, then they go, oh, well, that wasn't true. And they say, oh, because we figured it out. Well, then don't say from the beginning, trust the science, and then tell us why we need to, because now you've just ruined it. Now, why would I trust the science now? You've already explained, you've already shown us that when you say that, it means nothing. Huh?
I mean, Neil deGrasse Tyson isn't science. And honestly,
but I
couldn't care less what Neil deGrasse Tyson says.
I know that you might say that, but there's people that do.
On the globe side.
But there's people that do.
Can I just clarify, what was your actual claim there?
No, I haven't made a claim yet. I think we were just talking.
All right, okay. Sorry,
I'll go to my first claim. Sorry.
I thought we'd move to the claim.
No, we didn't. I was going to, let me get to the claims. I want to bring up this video and I'll show you. So this is the video I was telling you about. Where did this thing go? Can you see that or no? Should I keep forgetting if not?
No, you're not showing it right now.
Move it a little bit this way.
Oh, no, sorry. I'll bring it up. Let me use that bigger on my screen.
I got to figure out how to do this next time if I'm debating, because this doesn't really work very well. Oh, wait, if I move it to, hold on, let me check something. Maybe if I go like this, if I go to here and we move this over. Let me see if you
Is it OBS you use?
Yeah, I'm just trying to do, I have the thing set up for the, okay, now, let me try this one instead. Where's that getting that from? Okay, there we go. So you can see this now. People just won't be able to see you. Okay, so And this is the experiment by Life is Short, where he was out at the water here, and he's going to show you
feet.
The distance that he is away from. You can see this light here off in the distance is at 2.5 inches above the water. He has a little, where is he? Right there. There.
Yeah.
Trying to find the, come on, get there. Oh, I go to that scene. I see it on a little thing here. Okay, there. All right, so he's at, the camera height is the, a camera, iPhone turned on its side, but with the camera at the bottom. So the camera's about 1/2 inch above, the middle of the camera is 1/2 inch above the water. And then on the other side of the shore, 400 feet, is the camera, the light. I don't know why I can keep seeing it right there. See that picture of the blue? When I click on it, it's not there. Why is that happening? There we go. Oops. Let me go back and we'll catch it now. All right. So I'm going to pause it right there.
Arrows, you can go back and forward like.
Yeah, I got a J and L just to get there. Oops. I thought we were there. Not yet. And there. Okay, so.
It was there.
What's going on? What is that doing that for? Go back one. There. What is going on? It's even. Wow. That must be just there for a split second. Anyway, just showing you the height of the camera. So this is what I was talking about.
The truth, Jeran. You know that, right?
What?
It's NASA just stopping you showing the truth.
I wouldn't doubt it. Actually. Come on. So anyway, if it's 2.5 inches above and the camera is only 0.5 inches, how would it be that it's obscured? There we go. Okay, so here's the distance, 410 feet. The target is this light shining 2.5 inches above, and then the camera to the water is about 1.5 inches here to the observer to the water line. So why would it ever be that we wouldn't be able to see this light? Unless what we've been saying this whole time is true, and he'll show you here when he gets into the raising and lowering of it. Oh, no, that's over here. Here we go. So let's get to here. And he does a great job of explaining to you exactly why, because you guys all say that why do things disappear? I've heard Toon say it. There's no mechanism for things to disappear bottom up, and there absolutely is. That's what our eyes do because we are closer to the ground. In fact, if you turned upside down and got closer to the ceiling of a room, then you would see things do the same thing on the ceiling that they do on the floor. And he shows you here in many ways, there you go, showing you that by measuring these lines and looking when we're near the floor versus when we're near the ceiling, that you get different results. You can see them here on the bottom two results showing that what happens when you're low to the floor. Here's kind of a side view of that.
Disappear.
What?
Nothing's disappearing in his observations.
Yeah, watch here. I'll show you right here. So here's the light. It's hard because I'm trying to see over here. That's the debris. So to start out, let me just let you listen to this for a second.
This is 410 feet, and that near field debris
might not be
is the
loud
red
enough.
arrow in the left picture there in the low aspect of the frame. And then as I at about a 2-foot observer height, and then at about a 0.5 inch observer height, you can see how high in the field that piece of debris got near the purple.
So that's one thing that he's showing you here, just that I think people need to recognize, is that right here when he's up above, the camera's up higher here, 2 feet as it shows, you can see where this piece of debris is right here. Now, as he lowers the camera, okay, in no time, this is that debris. Because he went from 2 feet to 0.5 inches, this piece of debris rises up in your eye view and then almost blocks the other shore. This item almost blocks that shore. It doesn't even make sense to anybody because people don't want to listen to how observations work or how our sight works. They just want to believe.
Keep in mind that this is, let's say it's 10 to 15 feet away, and the
and if you imagine waves, so think of there's a boat way back here, okay, and there's waves here, and we're 6 feet tall, but then we get down and we're only 3 feet tall. Think of what those waves do to the faraway boat. So everything is explained as far as like things going over the edge.
The other side is
I'll show you this here.
Feet that I am.
What about when you're sea state 0 and there's no waves?
Say again.
What about when you're sea state 0 and there's no waves and it still happens?
Does the ocean ever have no waves? It has swell. It has.
Yeah. Oh my God! So many
shoaling.
times, Jeran, I've been out to sea in the middle of the ocean, And the only way you would know that you were moving was to look at the back of the ship and see the wake created by your
I would agree with that
propellers.
too, but that's not where we observe from. We observe from the shore, where there is always waves, because there's shoaling.
But my point is that the same thing happens in those conditions. I can personally, but I know it's just me saying and I can't prove it, but I have been in the middle of the ocean at sea state 0 and still seen the same thing happen when there is no waves.
Seen what happen? Boats go
Ships
over the edge?
disappear first.
Aren't you in a sub?
Not all the time. I spent a lot of time on board HMS Westminster.
Oh.
And the
my brother was on Carl Vinson.
Information.
Let me
and so what ends up happening?
Trying to find the actual raising and lowering of that light. Here we go. So now you can see
perfectly still waters. I'll put the coordinates on Google for where exactly I am across this lake.
But I think people don't recognize how
the distance of the light,
how huge this is in explaining what we see. Now he's showing you the 2.5 inches here.
So here we are. We're taking it at 2.5 inches. Just
so what he was 420 feet away? Did you say?
Yeah.
Here's the setup.
And right.
So watch this light. Look at this light.
Mile 5,200 is it?
Look how easily it disappears. Watch this light. It's a light. There it is. And watch, just when it touches, and the light is gone.
Immersion of the camera or anything under the water.
Gone. So we do lose things that are above our eyesight.
In a still shot.
Meaning that you can't let me get a little plane. Watch it. Gone. How is it being blocked? It's being blocked by the surface of the water, which is lower than you. See? Out.
Okay, so do you know exactly what refractive effects are going on here?
No, but I mean, you're talking about in 400 feet. Now we have to figure out. So this is what I'm saying. So if I say interesting,
the fact that it's 400 feet doesn't stop refraction existing, and refraction does exactly the same thing regardless of the distance.
So I thought refraction moves things. I thought refraction lifts things up.
Refraction can do anything.
Oh, so it does whatever you need it to do. I get it. So whatever observation we see,
the particular conditions dictate it to do.
You need to understand that from our perspective. From our perspective, I can't show you anything without you saying that refraction is the reason for it. So why even have debates? Why even
without knowing? Then that's the thing. I can't say for sure the exact reason for this because I don't have all of the data to say sure. Right. What I know as an absolute fact is that the closer you are to the water, the higher the refractive effects are, right? And I don't know the particular conditions of the temperature of this water, the temperature of the shore. There might be some inversion going on. I do not know because I don't have the data.
Okay, so if what you're saying, hold on a second. Okay, but if you're saying that there's refraction causing this item to go behind a supposed curve that's not really there, then in every case that you've said that you see boats go over the curve, couldn't it be the same? It's refraction doing it. Why not?
Again, we can to test that. We have to know the conditions. That's the thing. And the conditions when you're close to the water are always very different. There might have been some temperature inversion near where the light was. We simply don't know without the data. And here's the thing. I'm not going to go, well, no, that's wrong. It's refraction. Because I don't know. I don't know what the refractive conditions are there because I don't have the data provided. When it's something like that, when it's only 420 feet, there's no reason why there couldn't have been a few measurements taken of the barometric pressure.
He might have done it. But I think beyond that, again, I don't think you guys want the truth or you don't want.
Oh, I do. That's why I want all the data.
Yeah, but you think you already have the truth.
All of the data.
Yeah, but you think you have the truth. You don't think there's any percent chance. There's a 0% chance in your mind that you're wrong. So
no, that's absolutely untrue.
So I am willing. What is the percent chances that? What are the percent chances that the Earth is not a sphere flying through space?
I have no idea.
No, for you.
I don't have an answer. I don't have an answer to that question, but I will never say 100% that I'm right because we do not have all of the answers. But my personal investigation, my personal testing has determined that the evidence suggests the Earth's a globe and not flat. That's it.
So, and we bring you other pieces that should lead you down a different path, but I get it. You want every detail possible handed to you because that's
I couldn't look at that video you've just shown me and make a decision because there's not enough data there for me to make a decision.
But there is enough data there that should ring a bell like, oh, we lose things over the curve. And, oh, we've always told people that it must be because the item is behind the curve. That's the only thing it could be. And you're not being honest with people. You're not being honest that there is other reasons.
I've never said these things. And I don't...
Well, you've never said what? You've never said what?
I've never said that is the only reason. That's not,
Okay, so you've never said that boats going over the curve can only be explained with the curvature of the Earth.
No, I've said it's evidence for the curvature of the Earth. I've never made the determination that is 100% definitely what it is, because that's not what I do. And throughout this entire conversation, you have tried to tell me what I perceive as truth, but that's not how I work. My truth comes from data and evidence, right? That video doesn't have the data for me to make a determination.
Okay,
right?
So what about the boat that you showed me? The boat that you showed me earlier. What was the water and the temperature and everything there?
He actually did give us some details about the day. I would have to get it for you, where there were certain barometric pressures taken at certain areas. But that video isn't about things going over the curve. It is a response to the question of things zooming in, bringing things back from beyond the horizon. It's not a
that boat looked pretty close. What camera was that?
Actually, he has. I'm pretty sure it's a P1000, and he actually says at the beginning what the distance is to them. Let me check.
He knows the distance to the boats.
Yes. Right, the distant sinking ship, the Princess Paula, was 12.6 miles. The closer ship, the Glorious Mahuta, was 8.86 miles. The camera was 30 feet above the water. He was using a Nikon P1000 with 125 times optical zoom.
What? And then, so if the distance between the two boats was 4 miles, then less than 4 miles, right?
4 miles, yeah.
So, and then the drop rate at 4 miles is 10 feet. 8 times 4 times 4, right? So it'd be 16 times 8. Let me just get the exact amount here. Just because that would be the difference between those two boats. I'm just seeing 16 times 8.
Again, that video isn't really trying to show, oh, look, here's Earth's curve. It is just a response to the claim that you can zoom things back in once they've disappeared bottom first. That's all it is.
It's just, if you look at those two boats again, just think about it. There's only 10 feet of curve between them, and yet one boat is way lower than the other one, but there's only 10 feet of curve between those two boats. How in the hell would that ever happen? It can't. It's not even. It's just funny to me that we've just people have just accepted that boats would go over curves like that. That's what it would look like. Those two boats can't be 4 miles apart and be that drastically different. They look like they're on different levels, like of the Panama Canal.
Said they can't without knowing all of the data involved. That's the thing. You're making outright determinations,
right? Because I don't want to go to something that can be, like you said. So refraction can either lower or lift.
It depends on the conditions. Temperature inversions can make things lift up like we're on some kind of concave halo Earth. Refraction does.
When do we see things lift things up?
Well, actually, when I went to Antarctica, when we surfaced, the temperature was so varied between where we were and closer to the ice that it literally lifted things up, and it almost looked like we were in the middle of a bowl with the water moving up away from us.
It's funny. My brother says the same thing.
It's happening, right? Refraction can do insane things depending on the conditions. And my entire point here with all of these things is, without knowing the exact conditions, there can be no determination made about what is going on. And that's why I've said that without the data points, these things are pointless for trying to prove one thing or another. The video that I showed.
So if I went back through all your videos, how many times would I find you referring to something and saying that it was evidence of something, but really having none of the data points that you're talking about? Probably very often.
Again, evidence for something is different to me saying that this is definitely the case, right? What you just showed me.
I'm not saying anything is definitely the case.
Showed me, right, is evidence of something. It could be considered as evidence for the flat Earth. But the question is, does that evidence hold up to scrutiny?
Right. I would more even call it evidence that what we're being told by you guys is wrong. That's my point, is that we've got.
Yeah, by you guys, I'm not other guys, right?
No, but I think that I don't watch you.
Work.
I don't watch you, so I can't say that you. I just have a feeling that I would find the same thing from you, because I think, huh?
You know, you watch all my videos.
No, I don't watch any of them. I think the last one I watched, the last one I watched was Jenny was in it. Jenny was in the last video that I watched of yours, and then you chased her.
That's actually the last scripted video that I did, because I took a year off doing them so I could go to the gym and stuff.
Oh, there you go. So, so let me see, and then we've got. So anyway, where were we? Oh, yeah. So my claim is so much for the time. So much for the time periods.
The claim of that, right, was that it's showing that it's not Earth's curve, that it could just be the way that we view things, right?
Correct. And my claim would be that orthographic views are incorrect, because right now we just saw a situation where orthographically, if we drew that water 400 feet apart and we drew lines, it would show that clearly we can see the light at 2.5 inches at all times. There's no reason why we ever wouldn't. But yet people like Rufy and these other guys, they all think GeoGebra is the end all be all. If GeoGebra says it can happen, then it can happen. Well, what happened in this case? GeoGebra would tell me for sure that we can see that light 2.5 inches, but we cannot. And it gets obscured. And if you kind of start putting that out to further distances, all of a sudden, you're talking about, what do we say, 0.5 inches, lost sight of a 2.5 inches at 400 feet. So you can just keep doubling that and say, well, at an inch, we would lose something at 5 inches at 800 feet. And you could keep drawing that out. And before you know it, guess what? You could lose 40-foot boats at a certain distance when you're 6 feet tall. So that is huge evidence to tell us that there might be something different going on than we think. And again, I get it that people are going to say the same thing.
Let's go and say it's evidence. But again, for the evidence to hold up to scrutiny, we need all of the data. And without all of the data, I cannot scrutinize the evidence, right? Okay. I would accept that is evidence that vision may work a certain way. But that's it. It's evidence, but I need more data to hold that evidence up to scrutiny.
I would agree. I wouldn't expect anything different. All right, go ahead and make your first claim. Maybe we'll just do 2 claims each, and then we'll do this again.
It's gone on about.
Yeah, already at 2 hours.
So I'm going to keep it simple and talk about measurements and things that have been actually recorded. And I want to talk about reciprocal zenith angles, measurements of reciprocal zenith angles. Let me get this up on the screen.
And we have the
measurements of reciprocal zenith angles done by Jessica Kozlowski, where he took into account all the data that we need. Now, there wasn't pressure and temperature measurements made, but iterative testing was used to make the confirmations. And that means when, and that's something that can replace getting the barometric pressure and things like that, is if experiments and measurements are repeated constantly to see what the effects are at different times and be able to get averages and things like that. So Jessica Kozlowski used his surveying knowledge to take a bunch of measurements, and what these measurements basically were, where's it gone? Right, let me, right. So this is basically taking 2 theodolites and pointing them looking at each other and finding out if they are level. And obviously both theodolites are plumb to the ground. And what he did with these measurements was found that even though both are exactly plumb, they actually point away from each other slightly.
Well, he didn't find that. He assumed that. But go ahead.
So he found that from the measurements. There's no assumptions made.
There is assumptions made, because what if items get smaller in the distance and the Earth doesn't curve? Then we would see the same results.
No, let me finish.
Oh, yeah, you're on your claim. Go ahead.
Yeah. So by pointing at a level and knowing what the elevation above the ground is, and if one thing is level and the other thing is level, then they will point to each other, regardless of things appearing to be smaller in the difference. If one thing is 3 meters above the ground and the other thing is 3 meters above the ground, they will point at each other. And that doesn't change by the fact that one of the things will appear smaller when you're standing at the other thing. So what he found was, through iterative testing and iterative measurements, that every single measurement that he found was that they were above the 180 degrees that you would expect if they were flat. Every single measurement found that the reciprocal zenith angles meant that the plumb lines pointed away from each other. And the fact that there was iterative testing used means that the refractive conditions were accounted for via that method. And this can be repeated by anyone that has this, and any surveyor that can do this and come to the same conclusion. And also, I have many other instances of surveyors showing that zenith angles, reciprocal zenith angles, move away from each other. It's just empirical measurements. That's my claim.
Okay, so my claim is that those are not empirical measurements, that they're assumed because it's already you've already made the presupposition that the Earth's a sphere, and therefore you're assuming that because the reason why we see them not level is because they're falling away, not because they're smaller. But let me give you an example real quick. You tell me if I'm right or wrong about this. So you can see that. Oh, now you can. Okay, so just tell me. So if we were to want to see, let's say we had a cloud here, right? And this cloud is whatever, you can say whatever height it is. And then we've got a telescope somehow laying on the cloud. Just, again, it's a thought experiment. And then we've got, let's say there's some sort of stick here or something that we're trying to see if it stays level. Now, from behind that, these items are going to get smaller and smaller towards the horizon, right? Not from the side view like this, but I'm saying, let's say we got behind it, we would see them get smaller and smaller, right? So would this telescope actually be looking at the horizon then? If we got behind it and we look through it, since we know, like, let's say telephone poles would go down, 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 down as they go towards the horizon. If this is leveled and look, would it then see the horizon at the through here?
No, I mean, telephone poles don't go below the horizon.
No, but okay. So I asked, would this be looking at the horizon?
I'm confused. No, I don't understand your question. What's it looking at?
Okay, let's go with a different view so you can get an idea. So let's say we're on a
angles. There's two targets, right? That just had one target.
Okay, let's say these are buildings. Okay, these are buildings, and they go off, and but they're all exactly the same height, 100 feet. Okay, 100 feet. Now we've got over here a telescope laying on the top of this building, and it's looking off in this direction. Okay, now think about it. If we're looking from the position of the telescope, these buildings would get smaller and smaller and smaller off towards the horizon. Correct?
From your point of
correct.
I mean, if you're looking at the building, if you were on one of the buildings,
you're standing back here. This is
they would kind of, in your vision,
right?
They would kind of slope down,
right?
Yeah,
so then
they're still the same elevation above the ground, right?
Okay, so then then this telescope here would be looking down at the horizon.
It doesn't look down at the horizon because they don't slope down to the horizon.
So the horizon rises to eye level then?
No, it doesn't.
So which one is true?
What do you mean? The horizon doesn't rise to eye level.
So if it doesn't rise to eye level, but the telescope doesn't look down at the horizon, then how is it happening? How are we?
Well, the telescope isn't looking at the horizon. That's what, if you leveled if you were to look through the site, the horizon would be below that telescope. It wouldn't be level. That's the point, right? Let's say we put another telescope on that building to the right. Okay.
This one here?
Looking back towards the first telescope.
Correct.
Right?
Right.
Okay. Now, both those telescopes are, let's say, 150 meters above the ground. Right?
Okay.
That means that if we were to, if the Earth was flat and all refractive conditions are taken into account, that means that we should be able to sight one telescope directly into the crosshairs of the other telescope, and it would make a straight line between the two. Right?
Okay, you're saying that's what we'd expect?
Yeah, right. That's what would happen if I had a telescope on a building 4 buildings away that was exactly the same height, and I had both those telescopes exactly level, and I was sighting each other. They would, and the Earth was flat. They would both be looking exactly at each other, and it would be flat. But what we find is they don't. They would point away. They would look. They wouldn't be sighted directly at each other. It turns out that even though both those telescopes are plumb, they're looking slightly above the other one. That's what we're seeing.
Right. So when you're talking about Jesse Kozlowski, what he did was he has, a site here or whatever his transit or whatever, and then he has one here, right? And he's saying when he looks through both of them, he's seeing that they both dropped about 8 inches, right? So instead, now it's down to here. Now, the assumption is that it's because of this. That's the assumption. Sorry. You didn't see that. Let me see. You're right. I can't see that. Let me move this way a little bit. The assumption is that this is happening. So what I mean is you've got this, and then when he looks through his transit, he's seeing that it's a little bit short. It's 8 inches shorter, but they don't just assume it's 8 inches shorter. They believe it's 8 inches shorter because it's leaning. They don't actually measure that, except for this guy then measures back and gets the same thing, right? That's what you're saying?
I think it's not measuring that it's shorter. He knows the height of both of the theodolites. Let's say that the site of each of the theodolites is 1.5 meters off the ground. He knows that both of those are 1.5 meters off the ground.
Correct.
Right, and if you were to be able to construct a really straight thing between those two, then it doesn't matter which way you're looking at. That would still be a straight thing that went between those two things. But what you find is that you couldn't construct a completely straight thing between those things because they lean away from each other.
Well, you think that, but nobody's ever tried that. Why nobody's tried to build that between the two things, right?
Well, actually, some concave earthers did. They tried to, but the inherent flexibleness of materials.
Right, that's why I think can't really do that experiment. Right. You're talking about the rectilinear, whatever that thing was.
Yeah. I mean, the inherent flex. Nothing is completely rigid. That's the thing. Nothing is completely. No matter how tough a material is, it bends.
If you had unlimited budget, no budget at all, could you devise an experiment that you think could show, or I guess a better way to put it, a physical experiment that could show the Earth is curved with money's no object?
With a lot of extreme precision engineering, possibly. But it's very, very, very hard to account for absolutely everything in engineering all of the time. Materials warp. Let's say we were to start building something and we're trying to make it as perfect as possible. The problem is that there's going to be variations in that material during the day because the temperature. It's
yeah. No, I mean, I think it's one of the
possible, but it'd be a massive undertaking. But the point is, when you do these measurements and you take into account everything, it shows that they're leaning away from each other, and it's nothing to do with how it looks because both of those are the same elevation above the ground. So they're both exactly plumb, and if they're both exactly plumb, that means that their horizontals should be exactly the same. But it turns out the horizontals are not the same, which for me is evidence that the Earth is not flat.
Yeah, and for me, it's evidence that we're not taking things into account optically. We're acting as if things don't get diminished in size in the distance. Let me explain it. Like, this is the whole Rowbotham argument with the Bedford level experiment, right? Is that Rowbotham, and I know this is going to sound crazy to say, but this is what Rowbotham said, and I agree with what he's saying, that if you were to set up a telescope and it was leveled at your location and you were to look off at telephone lines, if you just leveled the telescope and that was it, and then looked off in the distance, you would see the telephone lines fall away from the telescope line. And he said that's not because the Earth's curved, because if you then angle the telescope at the first two telephone poles and then look, it will stay in perfect line with all the telescope poles forever. He says that's evidence that the Earth is flat. That if it was curved, what you would see, even if you aimed it at the top two telephone posts, is you would then see the poles fall away from that line of sight. And that was his whole argument against the Bedford level, is that what they did is by leveling it at the end. I know it sounds crazy because most people will be thinking, well, no, you do have to level it from your location. But what Rowbotham said is no, because things in the distance get smaller and therefore fall away from the crosshairs of the telescope. They don't fall away from the telescope.
They don't fall away from the crosshairs of the telescope. If both things are exactly the same elevation and those crosshairs, it doesn't physically change where it is. So if one is 1.5 meters above the ground and the other is 1.5 meters above the ground, then those lines are going to meet. Just because something appears optically smaller doesn't physically change the elevation that it is and where the lines would meet. The line coming from one, if it's perfectly plumb, would still go to exactly the same point on the other if it's perfectly plumb, if the Earth was flat, regardless of how small it appears to be in the distance.
So then, like, if you were to put a telescope on top of one cloud, let's say it's 10,000 feet high, and a telescope on another cloud 10,000 feet high, let's say they're miles and miles apart. Even though one of those clouds is at the horizon for one and at the horizon for the other, they're both aimed directly at each other, is what you're saying. They both would be in direct line with each other. It doesn't matter that things in the distance get lower towards the horizon. Basically, because you said earlier that if we look through a telescope, it wouldn't see the horizon. So you're saying the telescope on top of
not if it was plumb. Not if the telescope was set up to be perfectly level with the surface of the Earth. No, it wouldn't see the horizon in its scope. The horizon would be slightly below it. because the only way that the horizon is exactly at eye level is if your eyes are at sea level.
Okay. I agree with that.
Right,
I don't disagree with that.
That's it. Things, although they appear to be optically smaller, they're still physically the same size, which means that if there is a tangent line set up between those things, then that tangent line should meet them at the same point if the Earth is flat. It didn't. So that is evidence that the Earth isn't flat. Was that my first or my second claim, just so I know?
I don't know. I think it was your first. Let me do one more, and I will get back to that.
Right,
I got to
quickly take it so I can use the toilet.
Go ahead. What'd you say?
Toilet, loo,
go ahead.
Bog, whatever you...
I'll find which one of these claims I'm going to do. I forgot which one I want to do. What the hell was that? Oh. Let's play some music for you. Oh, damn, I think it's not working. Shucks, I had some good hold music for Craig there. Hello? I think it's working. Let's do one more claim each, and then we will get to your questions if you have any. Oh yeah, I remember what my last claim is. Okay, let me get that set up. What? No. Let's see if this. I wonder why this is not working today. If you guys haven't seen Don't Sphere the Truth's video series on Dave McKeegan's really, really good. You really need to watch it. I think he's only put out 3 episodes that I know, but they're all an hour long. Required 3-hour watching. Definitely check it out. And now let's get to some Craig music. Does that work? No. Of course not working today. Wonder why not. No. There we go.
All right, I am back. Sorry about that.
Oh, sorry. We'll stop your music. Okay, welcome back. All right, so here's my last claim. Let me put this up so you can see it. Shoot, where is this?
Oh, have you stopped your camera on?
No, it's picking up both things right now.
All right. Okay.
I didn't set it up for myself to be on the show, so that's why it's a little bit weird. All right, so I'm putting on. Oops, let me move this over here so you can get that. Okay, so you got that. So I'm going to flight 24 and going to ask you a question as to why is it that you think that planes in the south are refusing to use the known jet streams. I'll just give you an example. So we're going to look at Q. Oh, wait. So I don't think you can see the whole page, can you? No, let me move it over here. It's easier. Move it there. Come on. And let's go with here. There we go. Now you should be able to see the whole thing. All right, so we're going to... What? Oh, there we go. QF27 is the flight from Sydney to Santiago. Okay, it's about a 12.5 hour flight. So we'll go down here and we'll just pick any one of these particular flights here. And we'll notice that its distance is 7,000. Here we go. 7,062 miles. It did the in 1226. So we can do the math on that and figure out, you know, let's say 1226. Go down here. 1226. Oops. Sorry, do this way. So we've got 7062 miles divided by 1226. We'll just put 12.5 and we'll get out of that. So it's doing 564 miles per hour, which makes a lot of sense. That's about, you know, cruising speed for a plane. However, why is it that we, oops, hold on, let me go here. I had this ready. Bring this over here. Okay, so why is it that we go and we look into anything about the jet streams and we find out in all these cases, I'm going to just pull up a bunch of papers here. So we've got this one. What? We got this one. We've got jet stream forecast. All these pages will tell you that the speed of the jet stream in the south ranges from anywhere from 150 to 275. Okay, so let's get it on a low level of 150, which is the slowest that it would go And by the way, this is right now the current, oops, let me go miles per hour. If we go to 70 HPA and 10 HPA. Okay, so this is going to be the wind at high altitude. 10 HPA is way higher than planes go. 70 is about 42,000 feet. But just if you look how weird this is, that at the north right now, we've got a massive, let me put a different globe. Let me put a globe up easier for you. There you go. So right now in the north, we've got these massive circular polar jet stream flying like crazy. Mm-hmm. But in the south, we don't have anything. And you should have equal, at least the north and south should be somewhat equal. Now you could say it's because we're in the winter, and so we're getting this, massive whipping of the speeds. But which it makes it even worse, because it means that right now, if the speeds are 150 in the south, it means in their winter it would be 250 or even more. So let's say that it's 150. Well, we'll just try and see what this thing says. So we're going to miles per hour here. Where are we at? Miles per hour. We're going to go to 250 HPA, which is about 32,000 feet. We'll come down here to the south, and we see that there are winds whipping through here. And when we click on those, we're finding right now that's 203 miles per hour. There's 109 miles per hour, 166. So I think if we take that 127, I was going to take 150. It seemed a little 107, 123. Wait, where are we at here? This is, I can't even see. Is this South America? So let me see where I'm at. That's Africa. Okay, here. So if they're flying from Sydney here to Santiago, we're going to be doing this stretch. And we can see in here we get 136. This is going to be whipping through 153. It's going to be coming up through here, which is 130. So let's take it at 130 even miles per hour. So are you telling me that plane, which would max speed about 650, right? If you were to talk about, Mach, say 0.9 or something. So it's going 564. So is it actually going 420 miles per hour and utilizing that jet stream? Would that be your position? My claim would be that the planes in the south are not using the jet stream at all for some unknown reason. That or the distances are far greater than they tell us. And another reason I'll show that is to be the case. For some reason, even though I've got like this special account, I've got a gold account with Flight 24, it will never give me the GPS altitude, the true airspeed, or the indicated airspeed. However, if I go up and find a flight in the north, all of a sudden those numbers show up. So it's just that particular flight that I can't, if I want to see this plane, what it's doing, usually you can get, let me see what this is. This is LH493. So I'm just going to search for that real quick. LH493. So this is a flight from, go ahead.
This QF7, does it fly east or west?
27 flies.
Sydney to Santiago, right? Which way does it go?
Sydney to Santiago goes to the east.
It does fly to the east.
Yeah, and then it comes back also. But the one that comes back is a significantly longer flight, like 13 and a half or 14 hours. And then but it also has jet streams. You just need to get to the right flight level. There's jet streams going in both directions.
Jet streams aren't there all of the time.
They're there all the time. The jet streams. Here's the thing. Hold on. Before you say that, because I'm not going to let you say that. The jet streams are there all of the time. And you can go to any of these prediction things, and you can go way in the future. Look I'm going way to December 29th. They're never not there. The jet streams are always there.
But they're not always the same. They're not always constant. And also...
No, they're sometimes faster than others.
So is your claim that the plane should use the jet stream and it doesn't, just to clarify?
Correct. My claim is all the planes in the north use the jet stream, and they all go 800 miles per hour.
Not all planes. In fact, the majority of them don't use the jet stream. So here's the thing about jet streams.
Long distance, or are you talking about short distance?
They're a bit dangerous, right? Jet streams provide turbulent air, which pilots would rather avoid.
No, I don't think that's the case.
If you're taking about commercial airlines, they fly at altitudes that jet streams aren't even there in general.
No, that's not true. No.
Aren't jet streams usually a lot higher than commercial airlines anyway? So that they wouldn't use that.
No, this is right here. This is the jet streams going right now from the United States across to the UK.
At what altitude though?
This shows. Let me see here. Where are we at?
Because I generally don't think that jet streams are generally the same altitude that commercial aircraft fly. So I mean, I'm not.
Let me see.
Use them.
Stream altitude. They usually you can see like between, and this is what's always weird. It's hard to find the exact data because I can find 32,000 feet really easily. Basically says the altitudes of 6 to 9 miles. Yeah. So I mean, you're talking about. So 6 would be 30,000 feet, 9 would be 45,000 feet. So yeah, that's where, and planes can go up above 40,000 feet. So now we might not be told that that's what they're doing, but planes can go to the 50,000 feet easy, and the Concorde flew at 60,000 feet, right? So
in general, commercial aircraft just don't fly where the jet streams are. In
I just
general,
told
they're
you
not
that
going
I just told
to
you
go
the jet
out
stream.
of their way to use the jet streams.
No, it's not.
When there's
no, you're wrong about that. You're wrong about that. Every plane uses the jet streams. That's what they. Have you ever gotten to a plane when you guys take off a half hour late, but you get there on time? That's because
that's just tailwinds and headwinds. That's not necessarily jet streams. Planes don't fly in the jet streams because they're inherently dangerous.
That's what I was just. That's what they are. Headwinds and tailwinds. That's exactly what the jet streams are.
But headwinds and headwinds can exist without the jet. The jet streams are just specific circles of air, and not planes generally don't fly in the jet streams. That's what I'm saying. Jet streams aren't taken into account.
I don't know what you're talking about. Just stop saying words that you don't know what you're talking about. I mean, they do. That's what they do.
A headwind and a tailwind doesn't necessarily have to be because of a jet stream. Winds exist without.
Okay, look at right here. Can you read what this says right here? Can you read this? It says 7 miles above the planet's surface is equivalent to around 37,000 feet, which means that aircraft at cruising altitude slip easily into the jet stream. They all fly the jet stream. That's where cruising altitude is.
Well, so most jets fly below the level of jet streams, though. In general, the jet streams are slightly higher than the cruising altitude of planes.
It's not,
planes aren't going to go up that bit extra just to use the jet stream.
They're not going up any extra. Stop saying that.
They would have to be in the jet stream.
Read this right here. Here we go. Look at the jet stream. This is your Wikipedia. The strongest jet streams are the polar jets around the polar vortices, which is what we're talking about down south, at 9 to 12 kilometers. That's 30,000 to 39,000 feet above sea level. And the higher altitude and somewhat weaker subtropical jets. So the higher you go, the weaker it gets. 32,000 to 52,000 feet. The northern hemisphere and the southern hemisphere each have a polar jet and a subtropical jet. The northern hemisphere jet flows over the middle to the north latitudes of North America, Europe, Asia, and the intervening oceans, while the southern hemisphere jet mostly circles Antarctica, both all year round. Jet streams are the product of the two factors of the atmospheric weather, right? And it's basically air going from the poles to the equator and vice versa. But it'll tell you that their speeds are 150 to 250, and everything in everything in the north uses them, and yet in the south you can't figure.
You keep saying uses them. What do you mean? Do you have any evidence that all the planes use the jet stream?
Yeah, because if you do the calculations on it, they're usually going faster than like even the Mach speed because they're being pushed by the jet stream. So if you look up fastest plane.
You're saying that, but is there any? Is there ever been any pilots saying, "Oh, we use the jet stream"? Is there any citation that says use the jet stream? Could you show me any?
Yes, but pilots don't fly planes, so I guess it'd be better to ask for.
In general, pilots avoid the jet stream because it's dangerous.
Pilots don't fly planes like that. The computer flies the plane. The pilot does not steer in and out of jet streams. That's not how planes work.
The pilot can most certainly override the autopilot.
But I don't think the pilots override the
in general, the pilots will try to make sure they avoid the jet streams because they're the dangerous things to be in. You don't want to put the plane in more potential danger. That would be a silly thing to do. Pilots they can to generally avoid bad weather.
Yes, but the jet streams are not bad weather. They are what get planes move. The 801 speed.
That's not good weather.
Huh?
They're high winds, right? That's not good weather.
Oh, so here's one. Transatlantic jet stream was blowing 230 miles per hour, which caused this Virgin Galactic flight which usually goes 561 to go 801. So my
that's one. But your claim was that they all use it.
I will, and I'll find you. I don't know what you need me to find you. I'll find you that. All the planes can. Let me put it this way. Let me put it this way. Let me put it this way, though. All planes can use the jet streams if need be, and what it's decided by is what your scheduled arrival time is. So, for instance, if you leave New York late to get to California. They put you up at a jet stream level that will get you to California in time. That's why you leave late, but your plane arrives. Imagine if planes left late, the whole day would be ruined for every airline, for every people would be there'd be backups every day, but there's really not, because planes get to where they're going on time. They don't, even if they're an hour late, they get where they're going on time because they can make it up with the headwinds. And so all planes can utilize them. Not all planes do.
They can, but they don't all of the time. That's the thing. They're not going to utilize, the jet streams aren't always in exactly the same position, right? So you can't
pretty much are. They pretty much are. They meander throughout the year, but I'm talking about like day to day, they're in the same spot.
Right. And yes, there is overlap between the jet stream and the cruising altitude, but they're not always exactly the same. In certain circumstances, like normally in the north, you can utilize the jet streams to help you get to where you're going, but it's not always the case that not every single plane uses the jet streams in the north. Some might, but not all of them do.
Let me tell you why I say that. Because if you look at the south, okay, so the south, we know that there's that big distance flight of 7,000 miles, okay, and we know that the largest jet stream is in the south. I'll find you evidence of that. I'll find you papers that say that. The south has the biggest jet stream on the earth, and it moves anywhere from 150 to 250, they say. Now, for me, I could see it going 350. How the hell would anybody know? You don't break the sound barrier. You're just moving through the sky. Plus, and I could show you this video of Elon Musk basically spilling the beans and telling people, did you know, Craig, that the higher a plane goes, once it's at cruising altitude, once it's at cruising speed, that the higher it goes, the faster it goes for the same energy output?
Yeah, absolutely. Jet planes are more efficient in less dense air. It's why rockets are more efficient in a vacuum.
Okay, so why then would we not expect planes to be moving much faster in the south? So for instance, why is the record for the fastest plane in the north? If the jet stream in the south is the strongest, plus the higher you get, the faster you go for the same output, plus the colder it is, the more dense the air is, the faster the plane goes. Why would the record be in the north?
The plane might not be able to go up to that levels. It might not be designed to do that. To
what levels?
Not all planes can fly up to the altitude where it's a lot more efficient for the engines.
You're missing the point. So if there's a plane in the north that does, wouldn't you assume that there's a plane in the south that could do the same?
A plane in the north that does what?
Takes the jet streams and goes 810 miles per hour, whatever this one went.
But the jet streams are different in the north and the south.
And the one in the south is the faster one. This is my point.
Yeah, and that might be more dangerous then.
There's nothing dangerous about the jet streams. There's never been a plane that's been injured by jet streams.
They make turbulent air.
But there's never been a plane injured by a jet stream, ever.
Are you sure? Are you sure
I mean,
there's never been injured by the turbulence caused by the jet stream? Is that a claim that you're going to make 100%?
I'm going to say that, I don't think planes get really that bad at turbulence up there. And if they did, they would just drop out of the jet stream. So, I mean, the plane's not going to fall out of the sky. I mean, that's not how planes work. But
I'm not saying it's going to, but there's more chance of it getting damaged in turbulent air, and the jet stream has more turbulent air. The fact is,
let's talk to Wolfie on that one. I want to hear. Can you talk to Wolfie on that one for me? Ask Wolfie. I'm sure he takes the jet streams all the time. Ask him if it is a choppier flight if you're in the jet streams than if you're not. I've never heard that.
I will, absolutely. But again, right. So the thing is, the jet streams aren't the most important thing for flight times. Flight times are,
they are the most important things for flight times.
They're there to go extra fast. There might be times where they can't use the jet stream for whatever reason, but all of the flight times match what we expect them to. Nothing is out of the norm.
See this again. You leave yourself open for deception so easily. What if let's just say planes can go faster than we're told. Hold on, let me just ask you a question. What if planes can go faster than we're told? It's all programmed into a computer to get the plane where it's supposed to go on time. And you're here telling everybody because the plane gets there in the amount of time that we expect on a globe, that's evidence or proof of a globe. Do you understand that you're opening yourself up for deception? Do you not get that by doing that?
No, because I say evidence, not proof.
Okay, regardless of that.
I would scrutinize the evidence. I would not just go, well, there you go, blah, blah, blah. I'd look at the evidence and scrutinize it, and there's nothing.
But your idea of scrutinizing the evidence is to look at the flight times, and once they match what you expect on a globe, you consider that evidence.
That's not. No, you just making an assumption.
You just said that.
No, I would say that's one of the things I would do, but it's not all I would do.
I didn't say it was all you would do.
Of course, that's one of the things I would do. But if I was to really want to scrutinize that, I would look at a lot more. you keep making assumptions about what you think I do, and you're wrong every single time because I just do it.
Okay, so if I give you an assignment to do or whatever, you'll do it. You can look up these plains in the south and figure out why. Because again, the other problem is the same thing's happening with boats. It's not as drastic because there's no jet streams with the boats. But in the north, the record for the longest 24-hour distance done by a boat is way more than in the south, and that doesn't make any sense. It's just it does make sense in my world because I think the south is
in the south. A boat is done is longer than.
So in the north, the amount of miles done in a day by a sailboat is like 200 miles more than in the south.
Maybe there were stronger winds.
Possibly. Yeah, possibly.
Boats use winds.
Yeah. So, I mean, again, if you're just going to explain it away that way, even though it makes no sense logically that in the south, we would have 200 miles per hour less. The Vendée Globe, right? You do the math on that boat that takes, 100 days to go around. You do the math on it, it comes back that the boat was doing 4 knots. You look up the boat that they're in, and that boat does 34 knots top speed.
Not all of the time.
Again, you sound like Toon. Toon was telling me, he's like, well, they have to sleep. I'm like, they don't sleep. He's like, what do you mean? They can't race for 100 days and don't sleep. I said, go look into it. I've looked into this stuff. You have not. They don't sleep. They sleep for 5 minutes every hour. That's how those, they're in a race. They don't sleep and park their boat.
They're also not going 32 knots the entire time.
No, they're doing an average of 4.
Go that fast.
They're what?
Sometimes there's not enough wind to go that fast.
Sometimes there's not. But they do an average of 4.
Yeah. So what?
That's the slowest speed. That'd be like you telling me that the guy who won the record in a race car, he got the record and he was going 14 miles per hour. And I'd be like, why didn't he go 60? And he'd be like, well,
cars don't use the air. Wind at sea, cars have engines. That's very different.
No, it's not. What I'm saying is
sailboats at sea are limited by the speed of the wind that's pushing them. Yes. And the speed of the wind is not, there's going to be periods where your boat's not even moving.
Yes, there's going to be a few. Yes, it's going to knock your average down.
Backwards to actually get to the right thing to get you to where you need.
It's embarrassing for me because I don't know how many things can we bring up that there's no sea cables in the south between Australia and South America, that there's no sea cables between South America because it's a globe. It's closer down there than it is to go up along to Japan, along to Alaska, down the coast of the United States. That's way longer.
It's a lot harder to put cables underneath the entire ocean for that big distance than it is to just go up along the coast of the earth.
I would not think that's true, but okay.
But it is.
Why wouldn't it be easier to just take a boat and just go across the ocean? Why would you go up along the shore all the way by Japan and then up by Korea and by Alaska and Russia? And it just seems like that would be much longer to lay the sea cables.
Because the sea cables positions depends on what is needed and the countries that put them down and things like that.
Yes, but if you're talking about, shouldn't the globe be closer at here's a good picture here. So you can see this one. So what I always thought was incredible is if I took this map right now and bent it like a flat earth map, so I have to grab it and kind of circularize it, right? None of those cables would break. I would be able to keep all those cables exactly like they are. But if there was one cable going from Australia to South America, from South America to South Africa, from South Africa to Australia, if there was one cable, I couldn't do that. Couldn't bend it. It would break, right? So it's weird that the cables are set up in a way that makes you think, wow, that's weird. Why is there no cruises that go South America to Australia, South America to New Zealand? Why is there no cruises? And the reason why is because you would find out real quickly that that's a farther distance than you're told. So to me,
I checked the distances when I was sailing around the world, though. I can personally confirm that the distances are correct.
Yeah, but you did short distances.
Well, I also sailed around the world, literally through every ocean, and I've confirmed that the distances between countries in the southern hemisphere are definitely correct.
How did you confirm that? Dude, think about what you're saying. How would you confirm that? How would you, in a submarine, confirm the distances?
Because we sailed and we knew how far we went.
What do you mean?
We were in the boat and we know the speed and distance that we are going, so we know where we went between point A and point B.
So did what was the max speed of the sub?
Cruising speed of the sub, probably about 30 knots, maybe more or less, depending on certain conditions.
And did you ever were set at 22 knots or something? And
maybe but we know the speed we're going. Like for every second, we know exactly how fast we're going, so we know what distance we've covered.
How are you measuring that speed?
Against the water. There's ways to measure velocity.
But what about the current? How would you know if you're in a current?
Because you'd be able to tell that.
How would you be able to tell if you're in a current? If you're in a current, you're moving with the water.
You have sensors in your submarine that can tell you what's happening outside.
Yeah, but if you're in a current, there's nothing happening outside.
You can surface and confirm your position with other things like GPS and celestial navigation, which we do constantly to to confirm our position if we need to.
You do celestial navigation from your submarine?
Absolutely, you can surface and use a sextant. Why not?
I just don't think you're doing that. I don't think you're doing that. I got to talk to my brother. My brother was in the Navy.
Are you saying that you couldn't surface a submarine and use a sextant?
You could. I just don't think that that's what you're doing to travel distances in your submarine. I don't think you're like, we got to do celestial navigation to check out where we're at.
Saying that could be one way to determine.
Great, that's one way. But you said we did that all the time. You said, we do celestial navigation to determine where we're at.
I never said specifically that we did celestial navigation. I said that is a way that you could determine.
I'll have to rewind this because I thought you just said we use that to determine where we're at, and I said you don't actually use that.
I'm saying that there is other ways to determine against where you are. You can find out your position in many other ways, and I said that you can do that by surfacing, connected to GPS, using celestial navigation. All right, I've never personally used celestial navigation on a submarine, but I know that it's been done.
Now, what did you say you did with distances in the submarine? You told me something about how you had to basically dump all the fuel and then see how far you could get. What is that whole thing? Tell me about that.
Well, during sea trials, we were just testing the emergency diesel engines, which you would run. What if your nuclear power wasn't working? You would surface, pop on your diesel engines, see how far you can go. So to test the diesel engines, I would put in a certain amount of fuel, which should take us at X amount of distance, based on known consumption of fuel and power of the submarine, etc. So to test the diesel engines during our sea trials, we did a few journeys where we would load up a certain amount of fuel to see if it got us from point A to point B.
But you're talking 100 miles.
Probably not even that far, to be honest.
Yeah, okay. Just making sure. So that's when you say I verified that all the southern distances are correct. To me, that's where I just lose touch with you. I'm like, what is this guy talking about? How could you ever say that? Like that's
I've sailed the oceans. That's the thing.
Yeah, you were inside of a submarine.
Not just in the submarine. I spent time on surface ships. I was on board the HMS Westminster for a lot of time.
Nobody in their right mind would say. Okay, but nobody in their right mind would say that because I've sailed the southern oceans that I know that the distances between continents are correct. How could?
Because we can see if the distance between the continents is correct, and we are traveling at a certain speed, and we get between those continents, then we know that the distances are correct. They can't travel 70, 80 kilometers an hour.
Where did you go between two continents in the south? Because my brother was in the Navy. He basically went down to Antarctica. He did the whole polar plunge and all that. But he never told me that he sailed in the south. Like they never sailed from South America to South Africa or something like that. They didn't do that.
I mean, I did that journey twice, I think, actually. Once on board a submarine, once on board a surface ship. Okay. That's going literally from Southern America to Africa.
And no stops then at all on that trip?
No, they were straight journeys from one to the other.
And how many days does that take? And that's 24 hours of sailing, right? I mean, the boat doesn't stop.
It was probably about a day and a half each time, maybe a bit more. I'm not sure now.
It's a lot more than that.
When you're underwater, it's hard to tell what time is, to be honest.
You just got done telling us you know all the distances. Because a day and a half is, if you only doing, you said your boat did 30 knots, so what can you do in, what would that be, 24, 36 times 30? That's like 900 miles or 900 knots. I think it's a bigger distance between those two than that, isn't it?
It might, like I said, it might have been longer. It was a long time ago. I can't remember
anyway, all right, let's do your last. We've been going too long. Give me your last claim, and then we'll close her out. Oh, I got it. You're a funny guy, Craig. Funny guy.
I'm hilarious. Right, so I'm just going to go with simple Foucault's pendulum because I'm interested to hear your rebuttals to it. So Foucault's pendulum is simple. It's an experiment to see if the Earth is rotating by testing physical parameters of a rotating globe. If the Earth is rotating, like we say it is, then Coriolis forces are a thing, which means that a pendulum swinging from a pivot point will have different Coriolis forces acting on it depending on where it is on Earth. So if you are at the equator, the Coriolis forces are 0 because you're perpendicular to the axis of rotation. If you're at the poles, then it's the maximum that it's going to be. The gentleman physicist did this experiment and recorded it. Here we go. And managed to use nothing but the drift of the pendulum to calculate what his latitude on Earth was. So over time, they let this pendulum swing, starting on a straight line path, but over time it drifted, and they measured the angle of the drift. And using nothing but that angle and the amount of time that it took, you can use Foucault's sine law to calculate your latitude on Earth, which they did. I've done this experiment myself personally during my physics degree and measured my latitude in Bristol. This guy measured his latitude over in America. It can be done wherever you are in the world. The fact that you can use Foucault's sine law to find your latitude on Earth with nothing but the drift of the pendulum is evidence to suggest that the Earth is a rotating globe, because it's what we expect to happen. There's no other physical, mechanical explanation for what is happening. There's no other forces involved. It is simply what we expect to happen with Coriolis forces acting as they should if the Earth is rotating. So that is my evidence for the fact that the Earth is not only rotating, but it's a globe, because of the difference in Coriolis forces at your latitude.
So why would, in your mind, why would Einstein say that there's no optical experiment that can prove that the Earth moves if the Foucault pendulum existed?
He was talking specifically about Earth's rotation around the sun, not Earth's rotation, Earth's orbit around the sun, not Earth's rotation around its own axis. And he was specifically talking about interferometer type experiments like the Marcus-Morley experiment, which the Foucault's pendulum is not.
Okay, I don't think that's true. You're just saying that, but okay.
No, that's exactly true.
He said that, no, all optical experiments.
In that statement, he was talking about there's no optical experiment that can show that the Earth orbits the sun, because there's no way to use an optical experiment to tell the difference between the sun moving and us moving. So in that quote, Einstein was specifically talking about Earth's orbit around the sun, not Earth's rotation around its own axis. And it was in response specifically to why the Marcus-Morley experiment did not detect Earth's rotation orbit around the sun.
So if we were going to take relativity, what is our starting point if we're going to take relativity? Relativity is basically saying that we have to start with the assumption that all frames of reference are valid when describing motion, right?
I brought up specifically the Foucault's pendulum. It's nothing to do with relativity.
Okay. No, I was just trying to get you to see. Okay, so Einstein basically said that it's not proof, because if you had a large mass of objects outside of the Earth moving around the Earth, then you would get the same exact results that we see on Earth. You would get Coriolis force, you would get everything the same, right?
So Einstein did not say it would be exactly the same. Einstein said in a hypothetical scenario where there was a rotating shell around the Earth, there would be a minuscule, absolutely minuscule transfer of motion that could possibly affect the drift of a pendulum. He did not anywhere say that it would be exactly the same as Coriolis forces that we get on Earth. That is just wrong. That exact quote that you were talking about, he says how small the influence of a rotating sphere and the mass of that would be. So no, it does not say it would be exactly the same.
Okay, I'm trying to find it for you. Are you talking about, are we counting the paper written by, let me see his name again. I want to say Thermosol, but I'm Hans Thering, right? Which is called The Effect of Rotating Distant Masses in Einstein's Theory of Gravitation. Have you read that paper?
The thing that you sent me before, just written by a random guy.
No, that was somebody else. This is, if we, the framework, just trying to see where it's at, then small variables. Trying to find him say exactly that you said. However, we should not forget that in the problem discussed here, we normally did with point mass. By means of a concrete example, it has been shown that in an Einsteinian gravitational field caused by distant rotating masses, forces appear which are analogous to the centrifugal and Coriolis forces. The peculiarities corrected with this special case are thoroughly discussed. That's the summary of the paper written by this guy. So that's exactly what you just said isn't true. He says that in Einstein's gravitational field, distant rotating masses, forces appear which are analogous, meaning the same, right? Equal to. So they are exactly equal to the centrifugal and Coriolis forces, which is the forces that you guys claim. This is why, and you guys just can't admit this, I get it, Einstein would never have said that there was no optical experiment if the Foucault's pendulum was one. He said that because
no, you're getting that wrong, because Einstein was talking about Earth's orbit around the sun, not its rotation around its own axis. They're different things. You keep conflating the two. Einstein was not referencing Earth's rotation around its own axis. He said only Earth's orbit around the sun. So Einstein needs to be removed from the conversation, because Einstein's nothing to do with Foucault's pendulum, and nothing Einstein ever said that there would be an analogous result. This is just some random guy saying something.
Let me find you the paper by Einstein. It's actually for sale. You can find it. $10,000 right now. So he said, let me move this. Let me move my mouse over here, or move my.
But here's the thing, right?
Now you're going to try and change it, but you just said he never said it. So I'm just going to show you that he did say it, so that you don't say that again, because I don't like you just making shit up.
Has never said that there would be a rotating mass would make exactly the same as Coriolis forces on Earth. That Einstein himself nenever said that. When Einstein was talking about this rotating shell, he literally said that it would do something like a millimeter every 1,000 years.
Okay, here's a paper, Einstein. According to the general theory of relativity, one must consider that the Foucault pendulum adjusts itself to be rotation-free with respect to the total mass of the universe. Typed letter signed Albert Einstein with his handwritten annotation.
That's not him saying that the universe... Hold on.
It is. What he's saying is it's the same. So the person asked the question. Let me see what it says. The total gravitational mass of the universe determines the curvature of space-time and the inertial behavior of matter. The core idea of general relativity used to explain the motion of Foucault's pendulum and the rotation of the Earth. An important and highly condensed statement, almost enigmatic in its terseness, answering the question, when we ascertain a rotation of the Earth by means of Foucault's pendulum, is the rotation a motion with respect to the sun, the stars, or something else? In two very succinct sentences, Einstein answers, according to the general theory of relativity, one must consider that the Foucault pendulum adjusts itself to be rotation-free with respect to the total mass of the universe. This mutual influence should, however, not be interpreted as action at a distance. The total mass defines the gravitational field, the gravitational metric field in space, and this field defines the inertial behavior of the mass of the Foucault pendulum. What he's saying is, when it comes to the Foucault pendulum, one must consider, in terms of relativity, that it could be adjusting itself to the universe, meaning that it's not moving because the Earth is spinning, it's moving because the universe is spinning. So
there is no mechanism by which the universe spinning can exhibit the exact same Coriolis forces on Earth.
Yes, it's called relativity. It's called relativity.
And here's the thing. And here's the thing, because with respect to the Earth, the universe rotates at exactly the same rate all around us, right? So if we, everything moves at 15 degrees per hour, right? So, but on Earth, the Foucault's pendulum gives different results based on your latitude. So that can't be explained by
why doesn't
constant rotation of the universe.
Doesn't everybody spin 15 degrees an hour?
Everyone spins 15 degrees per hour, but the Coriolis forces at each latitude are different because of a different tangential velocity and a different orientation to the axis of Earth's rotation.
So wouldn't the sky be the same?
Einstein is not saying that the mass of the universe causes a rotation, a drift.
No, I'm not saying that he's saying it's causing it. He, of course, believed in the heliocentric model. He believed that the Earth was going around the sun. He believed the Earth was spinning. But he also didn't make statements that could be disproven easily by saying, no, the Foucault's pendulum is proof of the Earth's spin, because somebody would come along and say, like Mach, who believed that the universe was moving, Mach would correct him.
Mach had zero evidence for anything he said, but Mach was the one that came up with this Machian principle of the rotating shell and the rotating mass, which is what Einstein was referring to.
Correct, which is why he couldn't say that it was proof of anything.
Talking about that, Einstein literally said that if that was the case, then the transfer of motion would be so minuscule that it would be something like a meter every 1,000 years. There is no exactly the same. Einstein never said that the rotation of the universe could cause exactly the same that we get in Coriolis.
I just read it to you from a paper. Again,
it's been completely misconstrued as to what Einstein is saying and what he was talking about. Please send me that exact paper.
I will. And I'll send you this one too that says Einstein himself referenced Foucault's pendulum in context of an important 1912 thought experiment relating to Mach's principle, which led Einstein to posit both the relativity of inertial mass and the inertial Einstein lens Thiering frame dragging effect. Thiering is the same guy who wrote that paper. Einstein's historic 1913 letter to Mach. The present letter appears to be... What?
Again, nothing that Einstein ever said that, oh, Foucault's pendulum doesn't show that the Earth's rotating. And there's nothing to do. It's nothing to do with relativity. It is just a result of Coriolis forces, as we predict. There's no mechanism. There's no explanation.
But do you understand what relativity means? Do you know?
Yeah, I know exactly what relativity means.
Okay, so what does it mean when it comes to no matter where you're at, you can take it is a sufficient place to take measurements, right? I mean, like wherever, no matter where you are, you can call that a frame of reference that we can measure movement from. Correct.
You could, wherever you are, you can call that your rest frame. That's what it's referred to.
Correct.
And that's what we talk about with speed being relative, because everything would be relative to your rest frame.
Right. So if we're talking about all frames of reference are valid then for describing motion. Correct.
Yeah.
Okay.
All motion can be referred to as in reference to a frame of reference, and obviously all frames of reference at the same time.
So it would be impossible to ever say which one was actually moving.
If you were to purely take the relativity view of what was going on, but we don't just take that. We look at all of evidence in its entirety.
Not when we're talking about the Foucault pendulum, whether the Foucault pendulum proves it or not. You don't say it proves it because of other things.
Foucault pendulum has nothing to do with relativity, though.
Okay. What I'm saying is it does.
It was created before relativity.
It doesn't matter if it's created before. What I'm saying is that
and nothing in relativity can describe what the Foucault's pendulum is doing. All relativity is doing is saying that if you measure it from this point, it could be this or it could be this based on where you are.
Okay.
But that doesn't explain the mechanism and the what behind what is going on with the Foucault's pendulum and why the Foucault's pendulum is able to tell you your latitude purely just based on the drift.
Okay, let me show you
Nothing
this,
I've ever said disproves that is something that happened.
So I read this the other night on my show, and I think it's hilarious because. So this is what I always get from you guys. You guys always want to describe Foucault's pendulum and stuff, that it's being done all over the place and everything's on the up and up and everything's good. There's no problems. But yet then I hear that there's one done at the South Pole, right? And let me read you this paper from the Foucault pendulum real quick. This is the South Pole of the guys that did it. Let me make sure I have the right paper. Is it this one or this one?
Yeah, they had trouble setting it up a couple of times first. Yeah.
Yeah, many times.
Aware of that.
Okay, so
yeah,
but what did they do?
That's fine. There's no issue with having troubles setting up an experiment.
There is an issue.
That's the thing.
Okay,
you have to set up the experiment properly for it to work.
Okay,
and
but this is what you guys allow. This is what's hilarious. You would never allow this. If I came back from an experiment and I gave this report, you would laugh me out of the building. These guys basically hold on. They start out by saying abstract. The Foucault
gaslighted. You just said something that's not true. I wouldn't. True. If you went and did iterative testing and improved your methodology each time, which is what they did, then I would congratulate you.
Let me read it and then we'll see. So it says here, Foucault's pendulum at the South Pole was determined to have a period of 24 hours plus or minus 50 minutes. Okay. And the acceleration of gravity found. Then as you go through this, you start to realize that, first of all, they say that this was 100 feet tall. It's not true. It's only 50 feet tall. They lied about that the cable length was 33 meters. It's not. Then it says the South Pole is an excellent because they tell you in here that it's a 33 meter cable, but then they, in another paper or another site right here, hold on, let me find it right here. Nope. Here. Nope. Let me go back.
And did they write that other site that says that thing? So
no, but it's somebody who says what the let me get back here.
So the people doing the experiment didn't lie. Then somebody that wrote a website maybe got something.
No.
wrong.
The guys who did the experiment were wrong, not the guys who did the website. Let me show you. So it's this right here, this site here that talks about the tin. They call it the beer can. Here we go. The beer can. Oops, I'm in the wrong. There. Now you can see it. So this beer can page that talks about this beer can. That shows where it goes. It goes up here and then it goes down in the ground a little bit. And they show you the stairwell and they show you that it's 50 feet high. Okay, that's 50 feet. The most you can do is 50 feet. And it's going to show you right here.
And did they use all 50 feet?
They said that the cable on their Foucault pendulum was 33 meters.
Yeah, but
Yeah.
wait. So what's 33 meters in feet?
About 100. So this is, they look down from where they're at the top of the rafters looking down, and here it is looking up, and the guys say, oh, it's 6 stories. We had to go to the 6 flight of stairs. They're talking about these little tiny stairs as being flights of stairs. And then they even say in this thing, it's 50 feet tall. The ceiling's 50 feet tall. And then it shows these guys on their, where did I go?
Maybe they meant 50 meters.
Oops. Huh? Who knows what they meant? I don't know what they meant. How do I know that? Okay, so let me just get back here so I can show
Exactly.
you.
I mean, again, that wasn't written by the people that did the experiment. It was somebody else. So
okay, so somebody else was saying that they're, yeah, the person who was also down at the pole. Okay, so these guys are there here anyway. I'll show you where it says it. So here, there's even more problems with this though. So it says, excellent place here. Construction of the Foucault pendulum began by measuring out a length of guy wire, 33 meters in length. Then it talks about they drilled this hole at the top of a 2x4. And they said, and the pendulum wire was fixed in such a way that it would have freedom of movement in all directions. So now I know you'll just accept that, but I don't, because I say, well, what does that mean? How did you look at their drawing? Look at their picture here. How did you attach a 33 meter and then it had ability to move in any direction? How?
It allows it to move in all directions. That's
what they use. You said what?
They use a pivot point.
Okay, where does it say that? You just made that up. I mean, they didn't say that. They say that
that's what that is. That's a pivot point.
Okay.
Something that's hanging down.
Where, on here?
Is the pivot.
On here?
Yeah.
Where do you see it?
That's what a pivot point is. A pivot point is where something hangs from something and has freedom of movement. That's what they used.
What is it? Okay, explain to me what a pivot point is. You're talking about like a ball bearing that has no resistance in any direction, or what? Anytime
a pivot point is just something that allows you to hang from something whilst having freedom of movement, and that's what they designed.
But nothing what works like that. I mean, if you hang a string from anything, it's got restricted movement in one direction or two, right? So I just don't understand what you mean by a pivot point. What does that look like?
Something they hang from, allowing it to swing freely 360 degrees below it.
Okay.
What it means is it wasn't blocked off.
But let me show you real quick. Let me show you how intelligent these guys are real quick.
It was able to swing any way from where it was hanging.
Okay, real quick. Look at this picture and tell me what do you think these guys are very intelligent?
Well, they're at the South Pole, so I would assume it.
Okay.
But I mean, who cares what they look like?
Well, I didn't look at the weight that they've got ready there.
Yeah, okay.
You don't see any problem with that, Mr. I did this in my high school, college class, and you don't see a problem with the weight?
No.
This is a sufficient weight, you think, to do a Foucault's pendulum experiment?
I don't see why not. It's a mass hanging down. What's wrong with that?
Oh boy, I can't even fathom that people think like you. How do you not recognize that you can't have a weight upward? You cannot have a weight up like this. It needs to be equally weighted this way.
Why?
Because it needs to be. He said it's free to move in any direction. How you're telling me that if you started swinging,
how is it going to stop being? How with that way it's hanging is it going to not be free to move?
Because it's got wires coming up on each side of it.
Yeah, and those wires are going up to a pivot point.
So where's the wires on the side, this side, and this side?
They're going up to a pivot point that is connected.
No, I said where's the wires on the sides? Well, anyway, you're wrong because they eventually had to turn it the correct way and do it flat because it doesn't work the other way. Anyway,
yeah, because iterative testing to improve their
right because they have a goal that they're trying to get to. So look at here it goes. So
they need to make sure they're doing the experiment properly.
You mean it's not an experiment? It's not an experiment when you keep doing it to get the result you're looking for.
Yeah, that's called iterative testing.
No, it's not called iterative testing. It's called,
dude. It's not called. Exactly what you can't just dismiss iterative testing. I can
dismiss it. Listen,
improving methodology step by step.
Okay, so listen. So then they finally at the bottom of the stairwell, whatever, a weight was suspended from the wire, approximately 5 centimeters from the floor. After waiting for the weight to stop spinning and come to a rest, the Foucault pendulum was ready to operate. Great. The weight of the pendulum was released from an angle and the pendulum was started at the apex of the arc. We made a mark, whatever. There was no mechanism for keeping the pendulum swinging, so it decayed over a couple hours, so it had to be restarted periodically. So now they have to keep restarting it. If the period of the pendulum...
Yeah.
Yes, okay, so then they say we were looking for it to move 5 degrees every 20 minutes. So they would just let it go for 20 minutes, try and mark, and say, yeah, we get 5 degrees or not. And it says, by timing the period of the arc made by the swinging pendulum, we got a value due to gravity was calculated, okay, blah, blah, blah. The T was measured to be 33 meters. So G was, this is wrong. It's not 33 meters. There's not even 33 meters of room in there.
What do you think it was?
50 or 60. So feet,
no,
sorry,
T,
50 or 60 feet.
T was measured to be 33 meters. What's T?
Evaluation due to gravity was calculated. T was measured to be 11.5 seconds. L was measured to be 33 meters. L, I'm assuming, is the part of the triangle.
L?
Would be the part of the triangle that's the long end of the triangle. Yeah, that's the stick, the wire. Supposedly, there's not even room for that.
You don't need the wire in the calculations for Foucault's sine law.
You don't. Okay, and you know what? I just found that out recently. So you stand behind that it doesn't matter the length of the Foucault pendulum string.
Oh, it matters in the sense that the longer it is, the more accurate it can be, because you can get a higher duration of swing time.
But nothing would change
the shorter it is, the quicker the oscillation is going to be, and the more likely errors are to be introduced. But the actual length of the wire is not included in the calculations for Foucault's sine law.
Okay,
all you need is the drift over time, and to make sure there's no other factors influencing it.
Okay, let me show you this though. This is funny. So, sorry about that. Then it says here. So since the pendulum's period is independent of the weight of the bob, this experiment was performed with a variety of weights until one was found that gave consistent results. Okay, hold on. That's one thing. Standing on the bottom of the world, the Earth spins backwards relative to the direction it spins in the North Hemisphere. However, water spills down the drain in the same direction, whatever. Our first attempt with the pendulum showed that the Earth's spinning backwards from what was expected. We didn't notice this at first because we're all from the Northern Hemisphere and are accustomed to the Earth spinning in an anti-clockwise direction. We then realized that our frame of reference of the Earth should be spinning clockwise, so we had to modify the pendulum. What? You can't just tell me it's an experiment when you go down there and it starts swinging backwards, and then you're like, oh, we have to modify the pendulum. It's going the wrong way. So here's my claim. I think every one of you guys that's ever done a Foucault's pendulum experiment is a liar. I think you've all done it, and it's all taken you multiple times. I think it's taken you multiple iterations. I think, just like you call them, iterations, but you consider that to be okay because you've already been told it's a globe, and so you just want your results to be in line with what you think it should be, and then you're happy. That's all you guys do. You just confirm. What?
Like you just made something up. You just called everyone a liar without any evidence to suggest.
No, the evidence is that hold on. No, I did not. You say I have no evidence. You didn't give me a chance to give evidence. I've got a PDF installation guide.
I'm a liar. I'm lying about my experiment. The way
yes, I would guarantee there's no way you did it on the first try because you're all about iterations.
No, I did it on the third try.
Okay, there you go.
Because the first two times I hadn't removed all variables, and I needed to make sure that I had removed all variables.
Right. So again, people around the world are all doing
science. Iterative testing is science. Improving methodology is science.
But not when you have a goal you're getting to. If you need the pendulum to swing, let me just keep going with the story, because when you see how many times they get everything wrong until you're like, oh, so how about this? Our second attempt, the opening picture shows us three kneeling next to the pendulum with the weight hanging in a vertical configuration. The air resistance against this weight caused the pendulum itself to rotate. This gave us spurious results for our first attempt. Later, we fashioned the weight so it was hanging horizontally, and we got results consistent with what was expected. Our second attempt showed the Earth rotating in the proper direction, but an angular velocity twice what was expected, i.e. 12-hour days instead of 24. So thank God we don't depend on these people to give us answers in science tests, because they would come up to the conclusion that it was 12 hours. But no, because they know what they're looking for. Hold on, you're looking for something. You're looking for confirmation that you keep doing until you get it. That's not science.
Right. Okay, but then what if, when you keep doing the experiment over and over and over, once you've got all the variables sorted, you then keep getting the same answer?
Sure, they didn't do that though. They basically went and they said, we suspected some kind of government.
They might not have, but that's how a lot of people do it, right?
No, I don't think that's true. I do not think that the people that are out there doing it for their physics experiment, no.
Well, when the experiments are done, they are done by improving the methodology. When I did my Foucault's pendulum experiment, it took me 3 times of attempting it to set it up correctly. But after the third time, I then did the experiment 5 times to get my results. And each of those 5 times, after it was set up properly,
see what God did? See, God did it. God just came down and said, "Don't say that."
when there was all the variables were taken into account, and I set up the experiment properly, I then did the experiment 5 times and got the exact same results every time.
And I would, anybody who's out there listening to this, call me to your place, wherever it is that you've got one of these set up, and let's do it together. And I guarantee you there's no possible chance that you do it 5 times in a row and every time it's the same, because everything I've ever seen says, oh, it spins the wrong way. oh, we had to correct it. So
have you ever tried to do a Foucault's pendulum experiment?
I've never tried it. No, but here's the thing. I have a paper, a PDF for the one you can buy on Amazon. It's like $10,000 on Amazon. You can buy this little glass case. It's got the whole pendulum in it. Inside the instruction manual, it tells you how to start it, how to swing it, and then based on how it's swinging, to go and look up in this little guide how much to adjust it by so that it gets correct for your area. Now that's bullshit, dude. It's because it's a lie. It's a lie. And guess what? You can look everywhere and find.
I did it, and it wasn't a lie.
I hate to say I don't believe you. I do not think that
experiment that I've shown you by the gentleman physicist, he didn't have to do it over.
You don't know that. You don't know that. He made one fucking tape. He makes it look like he did it one time. Do you believe him? Just because he's on your team, you believe that he just did it one time?
Got any evidence that it's not true?
Yes. Every other time I've seen it done, or every other time I've looked into it, there's always these anomalies. How come there's a guidebook that tells you to set it going?
Now that there wasn't anomalies in mind.
What?
I'm telling you now that that's not true because there wasn't anomalies in mind. And in fact, pretty much everyone on my course got the same results.
Oh. Okay, everybody got the same result. I mean, it's just life's so easy
in a freezer. There's people that done it from a different building. There's people that done it from a fire station. That every single one of us got the same results when the experiments were set up properly. The thing is, when those people at the South Pole did it, they didn't set up the experiment properly.
Okay.
Once they set up the experiment properly and accounted for all the variables, it did what they expected. But the thing is, that's just some people just doing something at the South Pole. I wouldn't even call that like a proper experiment in the sense all the variables were accounted for, like wind resistance and everything like that. There was a lot of things that weren't done properly in that experiment. Fair enough. But they still got the result that matches all the other results when it was set up properly. And that's all you got to do is just set it up properly.
But it says they keep making further modifications to the pendulum. And then our last attempt showed that the Earth, then it says our last attempt showed that the Earth spins on its axis once every 24 hours as expected. That's the end, dude. They didn't reiterate the experiment.
They should have done more, right? They should have done more after they got that result, right? They should have done more to check, right? Absolutely. They should have done it a further 5, a further 10, a further 15 times to check that if that was the case, rather than just going, oh, there we go, we got the result, right? That was wrong. I give you that.
Okay.
But that's not the case when it's done all around the world, all of the time.
So what is it? Where's the one on the equator?
There isn't one because you wouldn't get any swing. You wouldn't get any drift. So why would you do it to see nothing?
So what if I say that I would bet that there is drift of the Foucault's pendulum at the equator?
You'd have to go and do it to check.
Okay. And then what would that tell you? Because here's the problem with us, because people always ask, why don't you do any more experiments? Like, why? What are we going to do? If I go to the equator and set up a Foucault's pendulum and it drifts, you're going to blame the experiment. You're going to say you didn't set it up right. Because you're going to say I should have kept. Hold on, let me talk. You're going to
help you set it up.
Okay, but
help you.
Okay, so what you would do is you would keep changing the fucking pendulum until we had no drift. You would keep.
No, I would simply help you set up the experiment properly and see what the results were. All right, I wouldn't do the experiment.
If we did it, if we saw drift, what would be the first thing you would say to do? You would say, "Oh, we need to adjust the pendulum." So do you understand that?
That's not what I would do. I would make sure the experiment was correct, and I would watch the experiment happen. Right. So let's say we set the experiment up, right, and the pendulum just started wobbling all over the place. That would be indications that it wasn't set up correctly. So let's say we set up the pendulum up and it span really, really fast. It would be an indication that it wasn't set up correctly. If we set it up correctly and we just let it swing and it showed that there was drift when there shouldn't be, then that is the data that we got. But then we would do the test over and over and over again to check. And if it kept coming up to show that there was drift when we didn't expect drift, then I would have to change my position. But it would have to be set up properly.
Yeah, no, I agree with that. I'm the same way. I mean, I wouldn't just take your word for it either. But because of exactly this reason, I would think that if I sent you down to go down there and you saw that it was processing or it was drifting, that you would change the apparatus until it did what you expect. And then you'd say now, and then you would write a paper like these guys that said, we went to the equator and did a Foucault's pendulum and it had no movement as we expected. That's what I think happens all the time.
That's not how I do it.
Okay.
That's not how I would do it. I would simply do everything in my power to make sure the experiment was set up correctly, taking into account all the variables. You test the experiment to see if it works properly, if there's things affecting it, and then you adjust it until you get no variables affecting it, then you let the experiment do its thing. And Jeran, if that was the case and it came up at the equator that there was drift when we didn't expect there to be drift, then I would have to scrutinize that evidence and change my position if that's what the evidence showed. But
well, both Austin and I have said that we would be willing to go down there with somebody, and we both would take the position that we would definitely see drift from the pendulum at the equator, because we think that you would, and I wouldn't even be surprised if, well, I guess I would be, never thought about that. I was just thinking about the fact of them saying they got twice the speed at the South Pole than they expected at first. Just trying to think if that's what we would expect on a flat Earth. I don't know. Mock that most cases. I mean,
there's no reason why on a flat Earth it would do what it does.
Well, one of the other claims I was going to make, and just something your audience can look into if they want. And here's my example of I don't think you guys would report anomalies. So here's what we found. We had people testing since basically July, August. What they were doing is if you take the time when the sun sets, okay, and I mean the top of the sun is disappeared at the horizon line. You don't see the sun anymore, but you see that residual light. If you start your stopwatch as soon as the sun disappears, as soon as the top of the sun goes away, start your stopwatch and keep going until you don't see any more light from the sun. Okay, that's all we're asking people to do. If you do that, you'll notice that there's a problem. That problem is right now, everybody on Earth is experiencing the same thing, and that is a reduced sunset time after sunset, or light time after sunset. Now, come December 21st, oh, sorry, my bad. I'm forgetting where we're at. Right now, we're all going to be increasing time, meaning everybody in the South, everybody in the North, everybody on Earth is going to be, if they did it tonight and they do it in a week from now and they do it in a week from now and a week from then, you're going to notice that the amount of time that you get after sunset is going to be growing. Now, in the North, it makes sense to us, right? If you live in the United States, it makes sense. You're like, yeah, we get longer nights. Therefore, coming into summer, we're going to get longer time after the sunsets of light. That's correct. Come July or June, where I'm at in California, you get like an hour and a half after the sunsets of light. Now, here's the problem. It should be the opposite way in the South, meaning that when we're getting longer times, that the South should be getting shorter times. Guess what? Everybody on Earth experiences the same thing. They don't tell you this. Don't go look into books. Don't go look into what twilight is, because twilight's based on it's a mathematical equation. It's basically 6 degrees, 12 degrees, or 18 degrees below the horizon. Don't pay attention to that. Go out and do it for yourself, and you're going to notice there's a problem. That problem is everybody on Earth experiences the same thing when it comes to reduced or increased time after sunset. The reason for that is because the Earth is flat, and that right now the sun is getting slower for everybody on Earth. Everybody on Earth is experiencing the same thing. So we all get extra time after the sun sets until June 21st. Then that's the slowest the sun will ever be. And then it will start moving back out. When it moves back out, it gets longer and longer and longer. And then everybody on Earth gets shorter and shorter and shorter time after sunset. So that's crazy that right now it's the dead of summer in the South. But those people
are backwards there. It is different. The day lengths go opposite for the.
Well, you'd like to think that, but I'm just telling you that you're wrong about that. And you can.
I mean, you can ask anyone in Australia in the middle of July, their days are shorter.
Okay, you're not listening to what I said. Listen again. I'm talking about when the sun sets, you start your clock till there's no more light. Then you end your clock. It has nothing to do with the day length times.
Right, I see.
Okay, so the reason that is because during this, right now, the sun is moving.
No, actually, you've said this before, and I've had this mathematically modeled out, and I have to show you because you're actually completely wrong.
How am I completely wrong? Observationally, or what do you mean?
I mentioned this before when we were having just a discussion, and someone actually mathematically modeled out what you were saying, and showed how you were actually backwards. I'm going to have to send you that.
Hold on, I'm asking you, am I backwards or observations are backwards? Which one are you talking about? The observations.
What you were saying.
Okay, I'm not. I'm saying
doesn't happen the way you were saying.
It observationally does. So here's how
anybody expect it to happen is the point. And you know, I don't have the data with me right now, so I can't go over it. And
so how many people do you know in the South? How many people do you know in the South?
Thousands.
Okay, find one person that can do that. Do that experiment for you. And here's all you need. Just have them time from the time the sun sets till there's no more light now, and then do it in 4 months. According to you, that number should be getting what? If they do it in the south today and then they do it in 4 months, what should their number be doing? Going up or down?
I'm not sure. I'd have to check.
Well, figure it out. Think about it. If they're in the south, so right now it's...
honestly, I'm not going to get into a hypothetical discussion right now because...
It's not a hypothetical. We can do it. We're actually doing a real life situation there. That here's the problem. You think it should be opposite, but it's not. Everybody on Earth right now, going till June 21st. So think about that. We got 6 months to do this. Everybody on Earth can test this. You'll all see that you're getting extra time. Now, if you do it every day, there may be a day that goes backwards a little bit because it's going to have to do with atmospheric conditions. In general, if you're talking about doing it once in January, once in February, once in March, you're going to notice that you're getting more and more and more time after the sunset. But guess what? Not just you, people in the south as well. Everybody on Earth experiences the same thing. Just telling you. And it's because the sun orbits the Earth extremely fast right now, goes around the Earth extremely fast, and it's going to start slowing down come June, and then it goes faster again out to December. So everybody on Earth experiences the same thing. And guess what? If you just think about that, that is the proof that you need, that you guys are all afraid of. That's why you won't look into this, because then all of a sudden you'll see that there's something
Come on, be fair. Don't tell me that I'm scared and I won't look into it, because that isn't fair.
Okay, I was more talking to your audience, because
I will always look into it, and so will my audience. All right?
I don't think so. That's what I'm saying.
Assumptions about people which aren't fair.
So here's how I tested this. I
have done my best to not make generalizing assumptions about flat earthers. I may have in the intro kind of explained my meaning, but I have done my best not to make generalizing assumptions about flat earthers. And I feel like during this discussion, you've done a lot of generalization and putting your thought on other people, which I don't think is fair.
Yeah, it's mostly fair. I mean, I think that I have seen enough to know that I've never seen a globe earther make a video that says, oh, I found this anomaly in my... Ooh, this kind of does lead to a flat Earth result. Nothing like that. It's like you guys
they haven't found any.
Okay, and you sound like Rufus. You guys are hilarious. Yeah, Rufus said maybe it's because
it is because they haven't found any.
Oh, right, Jesus!
Right, before we get to a final statement, let's
just go.
What is your data to back up the claim that you've just made?
That we had people doing that for the last 4 months. Basically verifying that was right before we came out with it. Now, I thought we were going to get better, like actual...
Send me that data so I can see it. Is that okay?
See what?
Would I be able to see that data?
Yeah, but I mean, this is the thing, is it's better if people do it themselves, because what are you going to look at? It depends on each person's...
I'm going to look at the data and compare it.
No, but there's no data if you're talking about the person's doing a stopwatch. So I can give you the day, the time, the location that they're at, and the amount of time after sunset.
I'd like all of that. Assuming you've got it in some kind of table.
But do you understand that that's not something that it's better if you do it from where you're at? For instance, if you do it tonight.
Okay, yeah, I can do it, but I would also like all of the other data so that I can look at it to see if what you're saying.
But the reason why it's different is because what your perception of what light is and when it stops is different than somebody else's. But if you do the experiment yourself and you have the same brain,
I'll absolutely do it, but I need other data to compare it to.
Got you. But do you understand what I'm saying? That if it matters, you can't look at somebody else's paperwork and say, oh, they got an hour and 15 minutes. I got an hour and 5 minutes. Well, maybe you both consider what light is differently. Maybe this person is actually looking at the light.
I'm timing what it is. It doesn't matter what light is. I'm just timing a thing that's happening. So that's what I want. That's what
and it depends what you look at, right? If you use your eyes, you're going to have the sunlight go away faster than if you use a camera. The camera sees the light for longer. Right.
Well, I use whatever everyone else has used. I'm assuming you've had controls and everyone's used the same thing, right?
No, each person can use whatever they want because it's their...
Oh, right. So, but you just said it could be different.
It could be different. So but hold on, listen, you're not understanding the whole premise of the entire experiment. The thing is, everybody on Earth, everybody on Earth right now is getting increased time. So it doesn't matter whether you use a different camera, doesn't matter if you use your eyes, doesn't matter if you use the light from the camera, doesn't matter if you're different than somebody else. You're all going to increase time after sunset, period. Now,
I want all of the data to show that it's increasing for every single person.
Well, you're not going to get any of that data. You're going to get only data saying it decreased because that's when we were doing it during the decrease. So we were doing it from June to December 21st.
Right, okay, well, I would like whatever data you have that is apparently backing up your claim so that I can...
Okay, but how hard would this be for you to do? If you do it, let's say you do it today and you do it January 15th, okay? Let's just say. And you see that for you...
you do it every day.
Sure, but there's not really a reason to do that because you're just trying to get a general idea, but if you want to do that work. But let's say that you should already know this, that your time in the north is going to increase, correct? Meaning the light after sunset today is going to be shorter than...
I want to.
Sure, but what do you think is going to happen?
I want to look at the heliocentric model, and I want to figure out what it should be.
Okay.
All right. I'm not going to make a claim here as to what it should be or shouldn't be.
No,
right?
but based on your life, have you lived here? Have you lived here for 40 years?
I'm not even going to make a claim as to what it should or shouldn't be right now. I am going to look at the heliocentric model and figure out, according to the model, what it should be. And then I am going to do the experiment and see how it compares to the experiment.
Okay.
Right?
Sure.
And then I will compare my data to everybody else's data to see if the increased percentage is what we expect or what we don't expect. Because
it's a lot easier than that, though. There's not even a percentage. It's simply this thing that if right now it's the height of the summer in the South, then they should be having the longest time after sunset, because in our summer, we get the longest time after our sunset. We know that. Come July, ask anybody who lives anywhere in the United States. I don't know about the UK, but in the United States, we all know that in the height of the summer, the amount of time we have of light after the sunsets is the most. And then it decreases on its way to December. Well, what we found out is people in the South were telling us we are going through the same thing. It's like, no, you're going towards your summer. Your time's going to be increasing. They're like, no, it's decreasing.
And I get that, Jeran.
As long as you get it.
Saying, but I just want the data. I want the positions of everybody that's done this and the data that they collected for those specific positions. That's it. That's not much to add.
Nope. Okay, we'll get that for you. Okay, outros, and let's get out of here. Oh, I got to do the super chat, see if there's any. And way too long.
I'll put any actual questions for you.
And yeah, we don't really need to do outros. We're fine. My outro is we're going to have Craig do the sun experiment so he can explain that one. And
let's figure out how to do a Foucault's pendulum experiment on the equator.
Yeah, I would even do one locally if I could. What do you think? Is there a height you have to be? I keep thinking somebody goes by your screen in a hat. It's fucking Saturn.
The higher the better, right? The simple. There is no specific height, but the more length of the string, the better.
So how high was yours?
I used the assembly hall in the main building at Bristol University West of England, which is got 3 stories at the side for different seating, and then a curve in the middle. We had a crane take me up to the very middle. So I would say I did it at about 35 to 40 meters.
Okay.
Maybe no, hold on. Maybe less than that. Let me think.
That's pretty high.
Maybe 25 minutes. Okay. It was quite high. It's the tallest building at the University of West of England.
And what kind of weight did you use? A sphere or something else?
I used a large block of concrete that was molded inside a foil casing, and then we took the foil off the outside. And not just foil, like a harder tin to keep it in, and we took that all off the outside. So it was just a concrete kind of sphere with a fishing wire, 3 fishing wires going right through the middle, and one had like a plug underneath that held it in place, whereas 2 went sideways and back up to the top to hold it so it didn't move.
Gotcha. Okay. And how did you record where like a pen on there or something?
I literally had a black marker that just would sweep along the floor just at the edge. The first time I did it, it was a problem because I had the marker too far down, and it was put in every time that it kind of hit the paper. It was too much, and the drag would kind of affect what it was doing. So I had to set it up so that it was kind of just scraping it.
But wouldn't the marker affect the pendulum swing?
That's the first time it did, because I had it kind of too far down, and it was like kind of kicking the paper quite hard. But when I got it just right, so that it was literally just scraping it just enough to leave a very thin trail, and in fact a lot of it was ink kind of flicking out of the marker as it went rather than actually touching the paper. It took like I said, that was my problems, was getting it so that there was nothing affecting the swing in any other ways.
Okay.
But the next time that I do it, I want to set up the pendulum above a bit of glass, and under the glass I want to have a camera just watching the pendulum, so that then we could put it into a computer later and actually track the path much easier.
Okay, let me see if there's any chats. I don't know. There might not be. And
Sub says for £5, Jeranism, how does arguing big boats didn't exist in 200 BC change the facts that we have oil tankers today?
Well, because again, you guys like to tell a fancy story and you all want to say that they proved the Earth was a sphere long ago, but it's not proof. We just disproved that there was no large boats. There was no boats going over any curve compared to their eyes. They didn't have any optics. They didn't have cameras. They didn't have telescopes. Therefore, the idea that boats going over the curve prove the Earth is curved is a lie. It's a fairy tale that you guys tell each other, I guess, so you feel good about life. I don't know, but it's a lie.
Evidence. Again,
it's not evidence because it never happened. It never happened. I saw boats go over the curve with my eye, but I brought them all back with telescopes and cameras. So how is that? So that means that it was not going over the edge.
It disappear, and then did you bring that back in? No.
No, but you're missing. How are you so fucking dumb? How do you not hear what I'm saying?
Oh, come on. I heard exactly what you said. You said you watched the boat disappear and
Correct.
You brought it back.
So do you see
like
that?
we said earlier, that's just it was too small. What you didn't see was the bottom disappear first, and then zoom in and bring that bottom back. That doesn't happen.
Okay, so but do people from the year 100 BC say that they proved the Earth was a sphere because boats went over the curve?
No, they just say it's evidence.
Okay, but their evidence was wrong then.
Again, I don't really care what people from 100 BC said.
Of course, again, nobody cares. But they sure like to tell these stories, and the Aristophanes story, which makes no sense, and everything else. Matthew de Gregorio, thank you very much, member for 2 months. Gifted 5 memberships, thank you. We've got Free Palestine, $5 says, Dear CGI Globe lovers, wishing you a wonderful globortion on our beautiful non-rotating flat Earth. We've got LJ.
Rene.
Huh?
That's Rene, isn't it?
Rene?
Yeah, is that the super chat from someone called Rene?
No, it's come from Free Palestine.
Oh, okay, maybe he's changed his name.
I don't know who that is. LJ, thank you very much. We've got Truthers Hour Comedy, $20 says, don't hold back, Jeran. Light this POS on fire. I like to let these guys just go. I think it's funny. I think it's, again, I kind of got angry there at the end. Projecting by FTFE, 3 pointing right back. Oh, point a finger, you get 3 pointing back. Gotcha. The globe is pseudoscience religion because it's full of hypothetical assumptions to impossible light years. Flat earthers are winning. Yeah, I mean, I think here's, and you tell me what you think about this, Craig. So I don't have any problems with doing debates anymore because I really feel that like there's nothing that you guys have at this point that's ever going to convince a flat earther to go to become a glober. Now you might say, "Oh, what Ranty switched over?" And
my chat right now.
Huh?
There's some in my chat right now that would disagree with you.
Right. So how many are you talking? People that we would know of, or
350 there? I think I saw STST there. I've got Ben there. He's an ex-flat earther.
Ben.
3 that I know of,
Okay.
that from watching the things that I and others have been saying, realize the Earth is not flat.
And they would say that.
So,
they would say it's because of things that you guys did. Because I don't think you're doing any favors for the globe. I really don't. In fact, there's a guy, Mindshock, that's covering. He's covering debates, and he actually thinks that flat Earth is a psyop.
Mindshock is fucking dumb as fuck. Oh my god, that guy doesn't even understand what a fallacy is. His video that he made on me the other day was one of the funniest things I have ever watched. I'm going to be covering that either tomorrow or the day after.
Wait, he did a video on what debate?
Yeah, he did a logical analysis of mine and Caleb's debate.
He already did that. I heard he was going to.
8 fallacies in the first during my presentation, where I just presented evidence. So honestly, Mindshock is dumb as fuck. Like
he thinks. Here's why I would agree with you. I would only agree with you because he thinks that flat Earth is a psyop because of how bad you guys are at debating. So, not debating, but how bad you are at bringing evidence.
I think we can agree that Mindshock is fucking stupid.
Well, if he thinks that flat Earth is a psyop, I tend to think that he's not seeing the truth about it, but I think maybe he just doesn't want to say that he's a flat earther either. I don't know. Anyway, let's continue on.
He's not a flat earther, but he is dumb. Do you mind the mean super chats to you?
I don't care. Yeah. It's money for you? Probably not. No. Go ahead.
Question for Jeran. This is from Kango44, 5 New Zealand dollars. What was it like growing up with parents that were brother and sister? Oofed.
Luckily, they got divorced. Jeran, how does your life change if you go back to the globe? FTFE, how does your life change believing in flat earth cosmology? My life would be better, to be honest with you, but I also have a need to have evidence to do that. And at this point, I can't even imagine what that evidence might look like because they've had 9 years.
For me, it would have to change everything that I understand about the universe. And it would be a humongous upheaval in my existential existence.
Okay. You're a an atheist? Would you consider yourself an atheist or agnostic? What would you consider yourself?
I know Steve McRae would disagree with me here, but I guess I'm an agnostic atheist, right? I hold the position that, I don't know, there could be a God, but there's no way to test or find out if that's true, right? I think personally that the universe is what we have been told, and it's billions of years old. Do I know what started the universe? Do I know why the Big Bang happened? Could there have been some kind of deity that made that happen? Could there be a God that set in motion the physics of the universe? I don't know. There is no way of knowing. But for me, I have no need for religion in my life.
You don't think there's obvious signs of intelligence or of purpose? You really think that the universe is just...
I don't know. I researched that answer quite a lot, that question quite a lot. And the answer that I come to tends to be designed by evolution. But there's a lot I don't understand, and I would never claim to have all of the answers. Is evolution true? Yes, I think evolution is true. Did some God set evolution in progress? I don't know. Maybe. I've got no evidence either way. So I think for the answer of God and things like that, the most honest answer is, I don't know.
Okay. And you think, between 65 million years ago and today, there was like a badger basically that evolved into a people?
I think that there is a common ancestor for all creatures on Earth. Yeah. It's what the evidence currently suggests. Could that evidence be wrong? Possibly. In the future, could we have better ideas of what happened? Possibly. But currently, based on the evidence and the research that I've done, I hold the position that there was a common ancestor for all life on Earth.
So why is there no animals from before the animals today? Like where's the pre-horse? Where's the pre-hippo? Where's the pre-giraffe? Why are all animals just appear in the fossil record? There
is lots of pre-things in the fossil record.
So I can name you tons of animals where there's no pre-anything. What was before a hippo?
The common ancestor of hippo and other mammals, I imagine.
Yeah, but you don't just go from that common ancestor to hippo. There has to be a progression all the way to hippos. Yeah. But the hippos
fossils are kind of here's the thing. Fossils are actually a rare thing.
I know. They all have these excuses. But
of bones don't stay around. They're gone after, a couple hundred years or whatever. Fossilization is a very specific process that not many things undergo.
Right.
But there is evidence of common ancestors, but that's for another discussion.
But we could go on for days on that one, because that one's one that...
Tug says for $5, Jeran, do you think that they don't show anomalies because maybe the Earth is a globe?
No, I think even if you did do that, you would still have anomalies. Even if the Earth was a globe, you wouldn't have every test result show that. It's ludicrous to think. It's ludicrous to believe that on a Earth that everywhere you are locally is flat. And I get it. I get that. This is what I don't even know if people understand, that if the entire Earth was a Home Depot and it was as big as you say, granted, if you put a level anywhere on the Home Depot floor, it's going to show level, no matter how far in any direction you go. In fact, if you took two levels and glued them together perfectly together and kept doing that you would go all the way around and eventually come back to where you started, even though every single level was perfectly leveled. So that's it's an insane kind of belief that either lends to being true or it's an easy cop out, meaning you could say, yeah, it's flat everywhere, but it's so big that it's actually a sphere that we just live flatness all over. That's your guys' position. I get it. But then if that's your position, then to pretend like every observation leads to a sphere is just false. It's just false. You would do tons of experiments or tests or observations. We know for a fact we can see too far. I've seen it myself. So in some cases, right? So if we see too far, then how would you just say, everything always leads to the globe? Well, then you're just a liar. I mean, I'm just going to tell you straight up. That's lying.
It's not that it leads to the globe, but it doesn't fall outside of the predictions of the globe.
Not when you have the Walter Bislin calculator. Nothing does. All you need to cover.
There are plenty of things that could still fall outside.
No, you can't.
Of the
You can't see it. Wait, hold on. You can't see through atmosphere.
Observations that we've had
you would never see further than those predictions. But you would never see outside of 1,000 miles ever. So
we don't need Walter Bislin's calculator to know that it falls within the predictions. That's just something that can help us show that. But the fact is, there is no.
Okay, but hold on a second. Do you understand if somebody was trying to deceive you? You don't. It's like you don't understand deception. If somebody wanted to deceive you, do you understand that by setting up the refraction number so that it always covered anything 1,000 miles or less, that then they essentially made it so that
then test refraction.
What?
We've got data that shows refraction is what we say it is, and that's the thing. Everything.
But you've never done anything.
Ever been shown shows that it's within the predictions of the globe. Nothing has ever been outside of the predictions of the globe.
Oh my God, I can't even take it. Nothing has been out the. Okay, so what about the black swan? What's going on with the black swan?
Everything, including refraction and everything, it always falls within the predictions of the globe.
What do you mean when we're seeing horizons way past where the globe horizon is supposed to be?
Again, refraction is included in the predictions of the globe.
Right. So refraction allows, no matter what distance we're looking, to move it up to where we see it on a flat Earth, or we see it like it's flat. And you guys are like, that's cool.
Refraction can do that. If it falls outside of what we expect refraction to do, then there'd be a problem. But it's never, ever.
I mean, I got to think of a good comparison with that. It would be like me telling you that my dog's a cat. And you saying, what? Well, we're just going to test it. And I said, well, yeah, test it. And, sometimes when we test it, I do have this graph that we go by. And the graph does show you that sometimes it leans towards this cat, whatever. So it's like you're just setting it up so that no matter what, either side of the coin, you even said tonight.
This is wrong because we've quantified refraction over the years. Over hundreds of years, refraction has been quantified. We know.
What does that mean, quantified?
Does.
What do you mean? How do you know that? What you'd have to know every single foot of
over hundreds of years, the effects of refraction have been quantified. We have Snell's law. We have Fermat's principle. We understand what refraction does under certain conditions, right? So if you were ever to show us a picture that would fall outside of any of the refractive conditions that we could possibly expect on Earth, then there would be a problem. But nothing you have ever shown us falls outside of something that can be explained by refractive conditions.
Well, I think it's awful convenient if you're allowed to say that refraction lowers or raises items, so that when items,
it's just a fact. It's not convenient. It's just
it is convenient because what can we possibly say if we're showing you things that are not?
Let's say it is convenient, Jeran, but it's still just a fact.
No, but if we're showing you things that are not supposed to be hidden, but they are, or things that we shouldn't see, but we do. And you're able to explain it away with a number, just by a word, you don't see it as being a problem there?
Well, no. Again, it's not just explained away. It falls within the quantification of refraction.
That's explained away. Same thing.
And we say, no, it's not. We put it up to scrutiny and we say, right, this is our physical understanding of how refraction works. And based on our physical understanding of how refraction works, is this observation even in the slightest bit possible if the Earth is a globe? Yes or no?
You've already taken the Earth. You've taken the Earth, which is 3959 miles, and you've increased it to be like 4,700 miles.
We haven't increased it. We've just said that refraction is a thing. That's what I'm saying. Right, Jeran, if there was ever an observation that couldn't be explained with refraction, there'd be a problem.
Do you understand that if they're deceiving you, then they've already set it up so that there is no observation that's outside of it? That's what I'm trying to tell you.
Show that they're deceiving us, then you need to disprove all the quantification of refraction.
I need to disprove the how would I do that? Explain to me how I go about that. Wouldn't one of these observations,
if we do experiments with light and disprove everything we understand about refraction, I would suggest starting with the works of Andrew Thomas Young, the current world's leading expert on refraction.
So why is it that when we look at like Mick West's sugar water experiment, what he's trying to show us the opposite happens, that we actually see things in the background being hidden behind things, which is what
experiment with the sugar water shows that the things that are hidden behind the horizon are lifted up.
No, they're hidden.
No, when he goes down to the camera and you've got the curve in the middle, it shows that the things behind the curve are now visible because of refraction.
No, I don't think we're talking about something different. We're talking about something different. I don't want to look it up now, but I'll look it up and I'll get that too. Because I don't think you're talking about the same thing I am.
Jeranism.
Oh, sorry. Jeran had. Oh, we already read that one. Craig Stinky. TLS girl.
I have a shower today. I mean, I do gym like every day, but I have showered.
You're just going to be like The Rock pretty soon. You're going to look like The Rock. Question for FTFE: how is the sun? Hold on. How is the sun able to maintain an axial rotation when we are told it's constantly undergoing nuclear fusion? Also, if there's 400 billion stars in our galaxy, why can't the ISS observe Obler's paradox? So the first question was about if the sun is able to maintain a rotation, and we're told it's constantly undergoing nuclear fusion.
One thing doesn't stop the other happening.
Well, I think I see what you're saying. So if the sun is rotating, how could it also be so? I guess the nuclear fusion is the process of pulling everything in. Is what's causing
nuclear fusion is when everything is squished together so hard that atoms combine, become a new atom, and release energy as the leftover bits as energy.
Right. So if that's happening, he's saying, how could it also be spinning?
The entire thing is also rotating. It doesn't stop pressure being in the middle. I don't know. One thing does not preclude the other. You can still have nuclear fusion with things that are moving.
Okay. I don't know about that. I'll have to check into that. And then also, if there's 400 billion stars in our galaxy, why can't the ISS observe Obler's paradox? So Obler's paradox, is that the one that says the whole sky should be white?
Well,
I think because there's stars, because stars coming in every direction. Sorry, at night. At night.
Oh, right. Well, there isn't. Space is massive. Is the answer? There is not stars in every section of space. It's as simple as that. And 400 billion stars in our galaxy is, for the size of the galaxy, it still means the galaxy is mostly empty, right? If you were to, let's say hypothetically, go to one side of the galaxy, right, and engage your warp drive, so you're traveling 10 billion times the speed of light, and just travel straight through the galaxy to the other side, you wouldn't hit a star because they're so spread out. It's mostly empty space.
Yeah, I think the best way to find that out is if you get, what is it called? Universe Sandbox was probably the first time I'd ever kind of gotten a big picture. And I just was amazed. Like, even though as fast as they say we're going, everything, you just pull yourself back from the Earth in real time and everything's just sitting still, which was even made it worse to me because it's like even more
question
numbers.
Jeran,
Yes.
Stringer News 1. What happens when you leave your straw man too close to the gaslight? No true Scotsman would do that. That's just funny.
That's not funny. I've heard the sun may be electrical, and that solar panels prove that. Heaters don't charge panels. What are your thoughts on the panel?
Oh, my God, he doesn't understand the photoelectric effect, but never mind.
Well, you want to explain it to him?
Yeah, my answer to that is just research the photoelectric effect. That will explain how solar panels work.
Okay, that was another Einstein thing, right?
Sorry?
Einstein? Photoelectric effect?
No, the photoelectric effect is just the fact that photons contain energy and can move things.
Okay.
It's not the heat that is charging the solar panels.
FTFE, do you like candy corn? Genuinely curious.
I've never had candy corn.
Oh. All right.
I like candy canes.
No, candy corn. It kind of looks like your haircut. Candy corn.
No, I'm just specifically after Jimmy Neutron.
FTFE, you keep claiming gravity creates the pressure gradient, but that's not true. Pressure is created by particles hitting the walls of the container, but it's manipulated by infrasound coming from space. Infrasound?
Yeah, just no. Gravity creates the pressure gradient because Fg equals gm1m2 over r squared. Simple as that.
Okay. So do you think? Do you ever think there could be a chance that, like, acceleration isn't F equals ma, or you think that's
force does equal mass times acceleration in Newtonian physics. That's a fact.
So it doesn't have to be true in the real world, though. Just it's kind of something men made up. That
it is true in the real world.
How so? Couldn't you think of something that falls outside of that? Like, for instance, if we have a item that falls from the sky and the item starts falling down, why couldn't that be that its own momentum is creating the force of it falling faster and faster and accelerating?
That doesn't make any sense.
Of course not.
Force is times acceleration. You calculate the force by taking the mass and timesing it by whatever acceleration it's under. That's never going to change. That's like trying to say, well, what if 1 add 1 wasn't 2?
No, that's a little bit different. It's quite a bit different.
It's as basic as that. F equals ma in the same way that 1 add 1 equals 2.
No. Yeah. That's so off. Yeah, oh my God, I cannot believe you said that. 1 plus 1 is equal to F equals ma. Unbelievable. Okay.
So 1 plus 1 equals 2 is analogous to F equals ma, as in they are as constant as each other. You 1 add 1 is always going to be 2 within hexadecimal, within
But there could
standard.
be a better system that works out as far as physics goes, that where they redo F equals ma. It's possible.
Wonderful. Then let's come up with that.
No, I'm not saying looking up, but it's possible. You're making it sound like I don't think there's
currently you cannot disprove that F equals ma. There may be a deeper explanation as to why, but F equals ma is always going to be true.
Yeah, I guess just the gravity could be either your magical pulling force or could be something else. In which case, weight is not necessarily weight. Could be gravitas, like it's said to be.
Well, that's just the name. If there's a different explanation for it, then that has to be presented, and it never is. But anyway,
well, it's going to take a little bit of time.
It's about time to stop because it's now getting to 20-4 for me.
Yeah. Okay. To set it properly. Oh wait, sorry. Here we go. Up. Where are we at here? Okay. If it's not Craig's beliefs, it's the scientific body of beliefs. It's not Craig's beliefs. It's the scientific body of beliefs that makes it scientifically proven and truly facts. Okay. Awesome Town Matt says, Craig, did you watch Mind Shock fallacy video with you and Caleb where you had 194 and Caleb 2 fallacies?
Yeah, hilarious.
194 to 2. I'm going to watch that after the show.
One of the dumbest people that I've seen, honestly.
I got to watch them even more.
That's after knowing Sleeping Warrior.
The Bible calls them the 4 winds of the earth. How many jet streams are there? 4. Good call, James. That's actually true. Too bad Jeran won't read it out. All right, James, how about that? If the earth turns under a pendulum, likewise it would turn under a helicopter. I don't think people understand.
Correct.
Yeah, I don't think you understand that.
Pendulum is not a helicopter. They would not act the same.
No, the pendulum is set to swing. The pendulum's swinging, and then they say that the earth is what. So when you see those pegs get knocked over, it's because the earth is supposedly moving the pegs into place. That's their claim. So I think people get confused when they say that.
From the reference frame of the pivot point of the pendulum, the earth appears to be rotating under it, and that's what would happen, yeah.
Correct.
Yeah.
But again, I don't think that's the case at all. Wait, and also no pendulum swings for 24 hours. Hello? Well, yeah, again, according to them, only the North Pole and South Pole would. And it would need help.
I think that they have to be restarted rather than keeping on going, yes.
Yeah,
if they did go for 20%, it would show 360.
All the ones have a little electromagnetism or a little magnet that keeps it going. Yeah. To set it up properly, pendulum at the alleged equator, how would he do it? Explain that instead of how you would make sure it's proper. Well, I don't think it would be very difficult. I mean, from what I can tell from all these experiments, if I would need to worry about whatever this freely rotating thing is at the top, but I understand what he's saying. If there's like something that's in a ball bearing that can go in any direction, then I see that. And then you basically, because I have a boxing bag in my garage which hangs from the ceiling. Same thing. It can go in any direction because it's sitting like on a mechanism that can twist in any direction. There's nothing impeding it from going any way that it wants. So I was assuming you just hang it on that with a long wire. Yeah, I figure you got to get 5-6 stories up, and you got to put a weight on the bottom that's quite heavy, and then I think it should happen. And again, you know, the best method I've heard is like you tie it with a string, and then you burn the string with a lighter to get a clean release. But in almost all cases, I hear that they say, "Oh, it started to swing in a plane, so we had to fix it." I'm sorry, not in a plane. It started to swing in like an ellipse, and they had to. Oh yeah, there you go. There's the string right there.
Right. Anyway.
Okay, almost done here. Almost done. Let me get the rest of these. The sun exciting the noble gases makes the most sense to me. Yeah, I think so too. I think that it does do that. There is no heliocentric model. The one they give us requires strings. What? There is no. Nice. Mind shock is king. Craig, you got crushed. Name one fallacy he pegged you for that wasn't a fallacy, and name a scientific group that measured physical curvature. That's from Ethan 0406.
The transcontinental triangulation of the American arc of the parallel. Mind Shock used ad hom fallacy wrong about 15 times. Mind Shock said that there was strawman fallacies when there wasn't. I'm going to go over the entire video because everything that Mind Shock said was wrong. The guy is dumb as.
Oh. Okay, I'll have to check that out. I don't know.
Even the fallacies that he said Caleb were doing were wrong. Caleb did not make the fallacies that he claimed that Caleb did. Mind Shock does not know what a fallacy is.
I don't know about that. All right. We've got Balicio. Balicio says, are we ignoring the declassified documents and flat non-rotating Earth? Are we really ignoring this? Nobody's ignoring anything, by the way.
Never classified. They're just modeling simplifications. Goodness me, I've been through this a million times.
But nobody's ignoring anything. We just had a couple topics, and how are we going to cover everything that you've ever heard about flat Earth? Day sidereal difference utilized to make the heliocentric globe, but the creator is obvious, and he made the world in a way to satisfy two models. Wow.
Whoop, whoop.
I'm designed. No, I mean, I think that's the weirdest thing about it, but I sometimes tend to go down that road. I'm like, really, why was it designed in a way that could so easily be described either way? But then I kind of look at, well, one of them isn't really described in an easier way. One is kind of grasped at, and it may not seem like it now because we grew up with one, but if you really look back, go back in the history of science and watch how they got to where they did, it was all, the story they tell now isn't anything like the real story. Like, I mean, Craig, don't you always hear like that Copernicus, his model was so much better than Ptolemy?
Yeah, but I honestly don't care about what happened in the past. As
right,
what
of course you don't, because it's crazy that the stories are false. The stories are meant to build up this idea, and I don't know why science is doing lying for what they have to know what that does. They have to know that once somebody catches you in a lie, good luck earning your trust back on that one. But it's, you know, the whole idea of how, what's his name, how they've just added Aristophanes to the story. You know, what's his name? Herodotus, who was after Aristophanes, was a librarian at the Library of Alexandria, which so was Aristophanes before him. And he wrote books and never talks about Aristophanes at all. Never mentions him, which is just crazy. But it's because I think most of our history was written after the fact. Anyway, I'm going to tune everybody out. People are going to call me even crazier than I am. What if I told you, Craig, that the moon is further than the sun?
I would ask for lots and lots and lots of evidence of that.
Yeah, well, I have about as much evidence that you have that it's
I would very
2,000 miles wide.
A lot more that we can go over.
Okay, we'll talk again. I appreciate you being here.
I appreciate you, letting me on to talk. There's a lot of flat earthers nowadays that just will not have the discussion. And I do appreciate that you allow me onto your platform so that we can have these discussions. Obviously, I disagree with everything you say, and I think you're fucking crazy. But you think the same about me, so hey, who cares, right?
Yes, indeed. What did we say the other day? I said something to you in a message. It was pretty funny. You said something like, can we talk or can we do something on your channel? I'm like, I don't know. I said, it's really pretty simple. I said, you think you're on a flying space rock in the vacuum of space, and I think you're fucking crazy. And I thought that was going to be good enough. Right,
I think you're fucking crazy because all the evidence that you've already got and you won't accept it. But hey, that's how it is. I don't think either of us will ever convince the other.
No,
but
that's not the point.
I do enjoy conversations with you, and I think I would definitely like to have more.
Okay, sounds good.
Well, while I'm here with you, I just want to say my apologies to you and your audience for postponing the debate with Whitsitt. I had a very severe personal family thing come up that I had to deal with. And I really hope that it didn't cause any inconvenience. And I really appreciate Professor Parks stepping in to fill that spot in the debate.
So do I.
But sorry to both you and Whitsitt for only giving you 48 hours notice that I needed to postpone.
We got through it. Thanks, sir. All right. And then James Richard says, I guess I should have said no pendulum would swing for 2 hours, not even 1 hour. 24 hours is absurd. No, they certainly are. Those guys that did it down at the South said they were restarting it every 20 minutes. So, all right. Thanks, Craig. Later.
Right. See you later. Bye.
Okay, I got to show one thing just because I think it's hilarious. Is this the second half of that? I could not stop thinking about this. I was like, oh my, and it's just too funny. Tell me if this sounds like Craig. Where is that at? Hello, over here. There. Oh no, that's not wrong. Where is it? Not that one. Not that one. Come on. There it is. Tell me if this reminds you of. I wish I wanted to play it right after he said it because it would have been funnier. Because now you're gonna be like, well, what part? Let me find it though here. I just thought it was so. I could hear it. I could just hear him saying it over and over again. I was like, oh my god, he sounds just like Justin Trudeau, like identical to Justin Trudeau. Let's see if I can find it. Come on, Trudeau, where you at? You're in here somewhere. Maybe I can't rewind while we're on the show. But I have to make a video of just going back and forth between Trudeau and FTFE when he was talking. He was like trying to make some excuse. And oh, there's the picture. I should have brought that up. I think it's right here. There we go. This was identical. When you see the comparison with what I'm talking about, he was talking exactly like this. Go. Can you see that? Where are you at? Over here, and let's put it on the coin one. This one. Oh, come on. Not that one. This one? Nope. All right, we'll move back over it. There we go. All right. What are you doing? All right, here we go. Watch this and tell me this wasn't just him.
Your family do to cut back on plastics?
We have recently switched to drinking water bottles out of when we have water bottles out of plastic. Away from plastic towards paper, like drink box water bottles, sort of things. There's a number.
I just got to go back and forth between that and when he was describing his experiment that he did. Oh, we had to put I had this one marker, and then we had it was like a black ink pen, and then we kind of put it, it was weird because we had to put it, like this guy.
Your family do to cut back on plastics?
We have recently switched to drinking water bottles out of when we have water bottles out of plastic. Away from plastic towards paper, like drink box water bottles, sort of things. There's a number.
There's a number of things that we're doing around, a number of different things that we've been doing. All right, let's get done with the show. What do we got coming up? We've got the big marathon coming up New Year's Eve. Ring in the New Year's with your boy, and we will have some fun. I've got already my list going of 100 things that I love. And then we're going to do some New Year's, not resolutions, but some affirmations, I guess they're called. We're going to do some of those. We'll have some giveaways. We'll have some new music. We've got, what else do I've got planned for that day? It's going to be fun. That is coming up Sunday night, December the 31st, probably starting around 4-ish Pacific time, somewhere in there. And then we'll see how long we go. Maybe we'll go out in the garage. We'll play some pinball. We'll have some fun. It'll be a good show. So join me for that. If you have nothing else going on, New Year's Eve. And Friday, we got the Jeranism show. So tune in for that. I'm trying to think if we are going to do... I might do Speaker's Corner tomorrow. A couple people have been asking for it. We might bring that back for a quick one last time for the year. And I believe that's it. If you're interested in debating on the DEBATISM show, let me know. We've got tons of Globers lining up. We've got a lot of Flat Earthers, so it gets kind of iffy because a lot of these Globers I can tell are kind of seasoned, and the Flat Earthers have never done it before. And I'm not sure if that's something I want to do, if I want to put that on my channel and then, take the abuse I get from Flat Earthers saying, you set it up, you did it on purpose. Something stupid, which they will surely do. Or how to exactly go about that. To me, maybe I'm just a lot less worried than everybody else. Like, I don't see these guys saying anything of any substance at all. There's just nothing there. And if people are really looking for the truth, they have to see what's going on. They have to see what is the truth of this science they talk about. They've got these guys that are so confused, they talk in circles around themselves. How many times did Craig say tonight he has no beliefs? Then immediately into something about something somebody else did and how they did it and how, I don't have, and then it was just back and forth. And I think those things are obvious. Now, if anybody is sitting and watching this and at the end of that says, oh, I think the Earth's a sphere because Craig really knocked it out of the park, then I want that person gone. I don't want that person watching me. I don't want that person to be a flat earther. If that's what's going to take you back to the globe, that's like why nobody frets about Ranty. Nobody gives a shit. Because if all Ranty did, which was come on all of our shows and present things and show every observation he's ever made from here, from there, everything shows too much. And then one day all of a sudden he's just like, oh, this one image shows that the Earth can't be flat. And it's an image that can be easily debunked. Then you start to have to wonder, like, what the hell's going on with that? Why would he? That's like, why would we want somebody who's that fragile? And then he goes over and starts hanging out with all these guys and being on their podcasts and making money. And he got a bunch of money from covering the Amber Heard trial, and just weird stuff starts happening. And you're like, oh, why would we want somebody that weak anyway? We don't need people like that. We don't need people like that. But I think that the people that are flat earthers who see the truth, like, it's going to take huge evidence for us, at least for me. Huge. Now, whether that's me going to space or if that's, I'm not sure at this point what they could really do. That's why I asked him about, if there's no cost is involved, what is an experiment that we can do? Because for me, again, the two are so far that I think are cheap enough to do and also could provide sufficient results would be let's bring this up real quick. Let's go with this one. Image, canvas size. This works. Okay. So move this over here. It's going to be hard for me to draw over there, but we'll try it. Just to show you the two experiments so far. And if somebody's got other ones, I would love to hear them. I would love to hear any experiment that's not too crazy expensive, because maybe we can actually do some crowdfunding and get it done. And I'll tell you why each of these has not been done yet. But as far as the laser experiment, if you're talking about image canvas size, 1 second, I go 16 by 9. Don't like squares. There we go. So if we're talking about the canal experiment, really nice place over here near me. It's about an hour from me. What is going on here? Come on. So you have this body of water that is the Sacramento River, really it's tidal. It's from the Pacific Ocean, but it barely varies in like feet by like 1 or 2 feet. And if you catch it at basically like the parabolic flight, if you catch it at the top of that arc, you can have about 4 hours, 5 hours where there is no much change at all. So anyway, you've got this water. Next to the water, there's like a little hill. Let's put some green here. I said green. Okay, it's just some hills, some bushes, easily to get down to. It's not very high. And then next to that hill of bushes is the road, which we're going to make gray. Okay. Very simple to do that. And we've got I'm sure you've seen it before, an auto leveler. Basically, we would set it here on the ground, and I can't draw that far away. Let me go here. Oops, back here. Okay. Let's go this way and a little bigger. All right, so if we take that auto leveler and we set it on the street, and then it levels itself, and then it shoots a 360-degree beam all the way around. So somebody then goes and stands next to the water, we have a big long tape measuring stick, put that in the water, and then see where the beam hits the stick. Now we know how far it is here on this part of the road. So you do that for each spot, and now we know that the road is, and it might be different from each spot because it's going to be measured off the surface of the water. So let's say that this is 4 feet to the road, and this is 4 feet to the road, and this is whatever, 3.75. Okay, great. So that's our feet. And then you construct panels of, we'll put these as the panels a little bit off there. So you've got these 3 panels. Oh, I should have done, hold on, let me just add a little something here. I forgot about the back end of it. Apply. Okay. And then we got this one here. I don't know if I'm able to grab it. Work for me. This one. And nope. Good enough. Try that. Go. Oh, go. Okay, there. All right, and then at this back wall we have a whiteboard. And basically on the whiteboard you just need to put markings on it, and this whiteboard's huge too. It's ours was like twice as big as the other boards. But let's say your markings are at here and here, and what that is this 10 feet apart, and they're flat Earth and globe Earth, and I'll show you why. So then you have and of course, it's a very rudimentary mock kind of setup here. Then you have your laser here. What color is that? Black. Smart move, Jeran. White. All right, so you got your laser set up here. Again, these are 1 mile, 2 mile, 3 miles, and then the 4th panel is at the 4 miles, which is a long distance. Now, let's say we take this laser and we get ready to shoot it. We level this off. It's probably a little too high. We'll lower it a little bit. All right, there's our laser. So then what you do is you measure if this is 3.75. We figure out what this hole is exactly. We want them to all be the same. So let's say that we go, let's say we go 4 feet, 0.25 to put this at exactly 8 feet. Okay, so we put this hole at 8 feet, and now we know that every hole needs to be at 8 feet. So we get here a little bit closer. There we go. So, and then the way we wanted to do it was 6 inches circular hole and hold the beam within that. Let's just do that. And then you go here and you would measure 4 feet up from there to get your 8 feet, wherever that is. Then you would do the same thing on this panel, measure up from your street, 4 feet. And we go here. Okay, so now you got 8 foot, 8 foot, 8 foot, 8 foot. And you would know that if the earth was curved, you would expect it to hit, well, this is kind of, stick would be way higher. But, if the earth was flat, you could hit this board at exactly that same amount, right? Meaning that you're going to thread this needle through each hole. Come on, where's the stick? Line, there we go. So if you take this and you would just basically thread this needle with a blue laser or something, and then it depends where it hits the board, because you can get it through those holes no matter what. But the problem is, where does it hit the backboard? Because right here, obviously, this would tell us right away that each of these holes was cut too high, right? Which is why we could thread it, but we're going up. And if it's flat, really the only thing you'd be able to do, let's say we just did it straight, is it would have no choice but to hit the circle, the circle, the circle, and hit the board at exactly the same height as all the circles. Now, if you threaded it through this needle and it hit this whiteboard way up high at the marker that we had set, well, then that means that the last board has actually been dropped down a ton, and that's why you're hitting the high. Part of it is because when you threaded the needle between these three, making them coplanar, well, the last one's going to fall way out. At least in my mathematics, I even didn't think you'd be able to get through 2. I thought that you couldn't get this laser through through the third, if it wasn't flat. It's just kind of my calculation. I'm not really sure how true that is, but regardless, we just wanted to see where, if we landed. And again, we lost the laser. It was melted to the beam expander. And then basically we just learned the second time that there's no way we can keep that beam 6 inches or less. And what happens is when this beam comes through and hits one of these sides of these walls, okay, so let's say the beam's coming through and it hits this hole, any part of that beam hits the hole and the whole beam gets broken up. It's called like an interference pattern. So then you just get this spread hitting the backboard and it looks like snow, just in every direction. And you just know right away, okay, we didn't do good there. So I looked into getting this is why we haven't done this again. We need a laser that goes 4 miles. Oops, I'm trying to draw with that. We need a laser that goes 4 miles and keeps a beam diameter of 6 inches or less. And we did find 6 inches or less. We did find somebody who has one that makes the specs like that, but they won't guarantee it because they said, oh no, this is in a lab and this is mathematical. It's not real world application. So the problem with that is, I wasn't going to spend $4,000 on a laser to find out that we get out there and it doesn't work. So my guess is for one that would absolutely guarantee to be working would be about $10,000. And the reason why is because the laser that keeps a beam diameter like that is extremely expensive. When we did 4 miles in Monterey, the beam diameter was 10 feet at 4 miles. Right. Well, we need it below 6 inches because again, if this beam starts expanding as it goes out, if it ever hits one of these sides of these holes, then it causes the interference snow pattern and you get nothing. But if we can keep that beam diameter through these holes, then to me, Craig asked me tonight, would I accept those results? Well, if I can thread the needle through 3 holes and it hits the backboard 10 feet higher than expected, there's no other mechanism for me to see that as. That would be evidence for me that I couldn't be refuted. There'd be no other explanation. I would have to go back and measure everything again, make sure my holes were the same height, but that would be a repeatable experiment, right? That's something that's repeatable. And if we lined it up and shot it through and it hit the 4 foot mark or the 8 foot mark, whatever, 8 foot above the water, then that too, to me, cannot be explained as a globe proof or evidence or anything. The globe doesn't have an answer for that. The globe, like he said, the only answer would be that the light beam itself is bending perfectly, so perfectly that it's hitting, because really, if you think about it, this is what's actually, they would say is going, don't do that. What they say is going down is this. If we take this and we go with a perspective, or I think we'll do bear. So what they actually say is happening is this. Ah, don't do that. Come on. So that's actually what they say is taking place, right? And if that were true, a little bit of this one, a little bit of this one. Oh, that would lift that up a little bit. So you can see that the problem becomes here, if this was happening, now you can see what this board drops right on the right. And that's what would cause, so let me drop that anymore. I can pull these down, I guess. Okay, so that's what's actually happening. So you could thread this needle, bink, 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 but you're going to hit the board way too high. And you would never be able to hit this board down here unless the Earth was actually flat. Now, again, their only explanation would be if we ever did see it flat, they would have to say, oh no, what's happening is the light beam is coming out of this, and it's actually bending perfectly with the curvature of the Earth. So it would be like that, right? So it'd actually have to be, the line of the laser would have to be bent perfectly, just like you see here with the curvature of the Earth. It'd be the only explanation for it. So that's a great experiment that we could probably do for $10,000. You're talking about less than $500 for every other bit of material. Just an expensive laser. We would need the boards like we used last time. Went great. Cameras, a couple people out there, and we're ready to go with that one. Even better would be like a stepper motor, some sort of stepper motor, or some way we could put the laser on a motor and we could actually fine tune, move it. Because if you ever, I know, I'm gonna say if you've ever, you probably haven't. But when you're out there and you're looking 4 miles, think of how far 4 miles is from you. That if somebody's like, oh, we don't see the light, or move it a little bit. If you just nudge it, it moves 20 feet on the other end of 4 miles. So it's very hard to get things dialed in exactly right. But what is nice is that we were able to, with these panels at least, go out, shoot the beam, and then carry the panel to the beam, intercept it. Now go to the next one. And so we just kept the laser on too long and it ended up melting onto the expander. So that's one experiment. Then the other experiment that I think is good is the water experiment with the fishing line, which I think we should be able to do. It's just a matter of what distance we want to do. I think Brian's flat earth test was talking about doing 2 miles. 3, I think, is a little bit better. What is the, let me see what the hump height is. Metabunk curve. So I want to see what the hump height is on 3 miles. I think 3 miles sounds best, but let's see. So we're going distance in miles, 3 miles. Viewer height in feet, not needed. We'll put 0. Okay, so we've got, if you're using the refractor, which you don't really need to, we're just going to go down here to the Sagitta. Oh, I got to click that button. That's what it is, advanced. There we go, and Sagitta. All right, so the bulge height is 1.5 feet, 18 inches. Now, it may not seem like much, but when I show you this, you'll be like, oh, that does kind of sound like that would work. So if we took a lake of water, and let's say that lake is 3 miles across, and we're going to put some little side panels here. Oops. Okay, there's a little beach on both sides of this water. Okay, so what we do is we tie off a piece of fishing line, monofilament, neutral buoyant fishing line. Let's go with this one. Okay, and we try and tie that to, not that, and this one. What's going on here? I said no. Okay, good. So if we take that fishing line, let's say it's this green fishing line, and we basically want to run it across the surface of the water, barely above it like that, and we want to use like a winch. You'd have a winch on one side. Right, so you basically have this winch here. Sorry for my drawing. And then you've got over here, it's secured to, say, this base here on concrete or something. So now we got those secured. We've got this wire pulled tight. We start winching it to see how tight we can get it. Now, granted, you're never going to be able to get it across 3 miles taut. You wouldn't be able to get it across 100 yards taut. So, but it won't lay down much. And if it lays down any, it will lay down on the water. Okay, because it's neutrally buoyant, means it's going to float. So let's say the line runs like that. We pull it as tight as we can. Boom, we're done. So when you pull it as tight as we can, one of two things is either going to happen. Either you're going to see this, where the line just sits on top of the water, or if it's a globe, what is basically required is that you need to have that cut into, where's this part? Here. So with this globe, you're going to have this body of water is actually curved. right? So it actually looks like, where's that street over there? Okay, so it's actually going to look a little bit like this. But the same thing is true. When we pull that green line, it should get into the water, right? Because it would be weird if it's just dragging up here. Why would, what would cause that? Now the it's sitting up here. It kind of doesn't make any sense. What would cause it to do that? It should pull through the water. You should get this line to come through the water, but it would only be through the water at 1.5, 18 inches though. But think of how big 18 inches is. Hold that out with your hands. That's a big distance. So that's how much the line would have to come under the water. Now, again, the only problem becomes if it just does float, which would be evidence of flat, it would be very easy for a glober to dismiss and say, nope, it floated because the line was too buoyant. The line was not. So I think sinking it to start would be good. And I'm all for giving them all the benefits of the doubt. Like if we took that and pushed it under the water, it just kept pushing it under the water, there's people in the whatever, and we just go the whole way, and then we say, okay, pull it tight, and they pull it tight, and we keep it like as close to under the water as we can to see if it gets down 1.5 inches. I guarantee it keeps coming back to the top, even though we're pulling it tight. So those are the two best experiments. I still think the laser one's the best. I've not found a better, easier to understand and explain experiment. But we shall see. We shall see. I think this is our best bet. I just don't know who wants to be in charge of that. It's probably not me. I'm talking about the other one though, not this one. I think that the canal one is still the best. And I even think our second observation wasn't bad. I mean, our backup experiment was just basically taking the light down there and then trying to see if we could see the light through the panels. And we got results for the middle. So that doesn't help us much. So we drove it home. All right. I believe that we are going to head out. I appreciate you guys so much. And we will see you probably tomorrow. I'm guessing tomorrow. I got some things to do in the morning, but that's it. Anything else I wanted to bring up? Let me think. If you want to check out Mount Meru, please do. Go to shop.trueearther.com, or you can call me if you want. Okay, I think that's it. All right, guys, much love. We will talk to you soon. I remind you, please do your own research. When you do, you'll never again believe all the bullshit you've been taught. What do you want? You want some music on the matter? You know you do. You know you do. Let's see if we can get some dancing here. What kind of dancing do we want? We want... Is it no dancing? Yeah, definitely check out these videos by Don't Fear the Truth. This is not enough views. He needs way more views than that. This is a $100,000, $200,000 view video. It is an hour, but it's excellent at debunking Dave McKeegan and his dead stuffed dog. Nice globe back here. What a sellout. What a fraud. You can just go to his channel and look at his channel too, and it's like videos are making like no views, no views, no views. Flat Earth, huge views. Back to other videos, no views, no. He Flat Earth big, and then he's like, now he's the Flat Earth king, I guess, over there. He's got all the pseudoscience answers that you could ever want. It's pretty cool. All right, let's I don't know. We need some dancing. I go to the bathroom. Let's go with this one. Looks like she's doing it. All right, guys.
Music, 3, 2, 1.
3, 2, 1. Guys, do your own research. When you do, you'll never again believe all the bullshit you've been taught. Till next time, this has been Jeranism. Much love and peace. No, we're going to play this song. I knew what I was saying. Now, peace. Love you guys.
I know this dude named Jeran and he's looking real fine. And no, I'm not a homo, but I gotta try to make him mine. Cause he holds all of the secrets that the ancients once kept. But the way to Jeran's heart is proving you have once leapt from a volcano or a cliff or an airplane into danger without fear, crying, screaming, waking babies in their mangers. He can smell your fear from 1,000 miles away. And if you try to deceive him, well, today's your last day. You can bet he doesn't want a coward or a liar coming up to him saying, can you be my friend? Maybe you can man it up and lay it down in front of him, show him you're strong enough to go out on a limb. He's got enough ladies lining up around the block to fill 747's loading number on the clock. A lot of men are crying every single day, praying for a Jeran day, but they can't afford the price to pay. All the women want him and all dudes want to be Jeran, but the fact of the matter is, there's only one Jeran. He's got an internet following that forms a giant group. He can translate ancient tablets using alphabet soup, which he rarely even does, though it fetches big money. He doesn't even need it cause he sweats pure honey. His fans send him gifts, make him gifs, jump off cliffs, just for the once in a lifetime honor of seeing Jeran take a sip of
his famous oat stew. That's right, he's a stew chef. You may say, what's a stew chef? Well, you've probably never seen a stew chef, cause there's only one stew chef, and it's Jeran cooking it up. He's known for only filling friends and family's cups with his decadent sludge that he boils all night, every night, all night, every night. It's out of sight. He can do a dance that makes everybody pee their pants and make a mess and cause stress. He's on a mission with the Jerry Berry Blitz and the Jerry Berry Twist. He's riling up the world. You can do the Jerry Berry Blitz and the Jerry Berry Twist. You can imitate the best just like the rest. Come on, Jeran, show the world what you got now. He's gonna show you his dance. He's gonna show you his skills. His dancing skills. Check him out, y'all. Grow with every fight, and every fight that he fights, he destroys his opponent and leaves a sticky mess on the ground. He wages war when provoked, and when provoked, he starts to smoke out of his butthole, and that's when you run away or die. Cities topple, buildings fall, mountains melt, and rivers stall when Jeran says so, cause he does what he wants when he wants. Sovereign nations all bow down when Jeran comes around. They know they can't match his skills, yeah, they've all heard this song. He's lived for thousands of years and caused innumerable tears and broken so many hearts, I just don't know where to start. His flow's unbreakable, swagger unshakable, his style's impeccable, and you can't do anything when he competes at Pizza Prize Bowl. Girls want to marry him, but a mate would only slow him down, and besides, you know that he would never ever share his crown. He's left everyone he's met depressed, torn up, and so forlorn. What's scary is you haven't even seen his final form.